Hi guys, good morning. Anyone there? Anyone is there? Only two people are waiting. That is, one is me, and I don't know about the other guy. So, as I said, since yesterday you asked me, I have created a link for you today, exactly at 9 a.m. So, if you have anything, please let me know. So, anyone present, guys? Am I audible? Am I visible or not? Please let me know. Anyone there in the class? Actually, two people asked me, not many people. Two people asked me for the live class, so I'm taking it right now. Am I audible, guys? Am I audible? Am I visible? Hey, hi, Manish Kumar. Like, love to you. Good morning, Manish. Good morning, sir. How to contact you, sir, to get guidelines for civil engineering? Pradeep, I think you have got my number. My number to contact is. You don't have my number to contact? I think I have given my number to contact. My number to contact 9873414725. You can WhatsApp me anytime, but I'll reply whenever I am free. Hello, Manish Kumar. Good morning, Manish. Good morning, Pradeep. Two persons asked me. One person is that Hemant Kumar. He is not there. Fine. Other person, yesterday only I have seen him new. His name started with some F. He is also not there. Hmm? You asked for the class. When I am there taking the class, why you are not present? Good morning. Good morning, Javed. Mhm. So let's wait for another 2 minutes. After that, we'll start transportation engineering. So today, I'll be starting transportation engineering. Starting in the sense, I'll be discussing transportation engineering from problems. Some problems we'll discuss, some concepts we'll discuss, and then everything. Good morning, Soumya. So some concepts we'll discuss and everything. Accordingly, we'll go with it. Okay. Mm, so I'm like, we'll take some from previous year's gate questions only. We'll try to attempt as many problems as possible. I'll wait for another 1 minute. After that, I'll start. So from morning till the time you want me to stop, I'll keep on doing it. Once you ask me to stop, I'll stop the class. Not a big issue. Please do like, share, subscribe with as many people as possible. Okay. Yeah, this guy, Finn Dakar, good morning. I'm waiting for you, Finn. Sorry if I have a spell. Hi, Kumar. Yeah, I'm waiting for you. Yeah, you two guys came. If you're not there for whole class, then I am not going to leave you. Okay? Instead of you messaging me, I will constantly keep on message you and irritate you. Okay? So you have to be there. I don't know about other guys, but you guys have to be there. Sir, please do problems more on traffic and pavement, sir. Please, definitely, Soumya. We'll go from the starting. We'll do all the problems. We'll try to clear all the concepts. Not a bigger issue. Fine, guys. Let's start. It's already 9:05. Time is more precious thing, and time is money. Time is life. It's a time is life. Time is not money. Okay. Now, let's go from the starting. transportation engineering. So there will be highway, railways and airport. And see, if you want concepts also, last year I have given, for while discussing in the engineering services in YouTube, I have given free classes. You can go through that. Okay. So now coming to the first one, introduction to the highway. Generally you don't expect much questions from introduction to the highway, but there was a question in GATE 2004 that is based upon the principle of utility. Principle of utility. So what is that being said? I hope, is it visible, or you want me to write this question once again? Please let me know whether the question is visible or not clearly. Three new roads P, Q and R are planned in a district. The data for these roads are given in the table below. Road length, number of villages with population, and then all those things data is given based on principle of maximum utility. The order of priority for these roads should be. He is asking what is the order of priority for these roads. So is the question visible properly, or you want me to write once again? Visible? Yeah, fine. Balu Rathod is saying it is visible. Fine. Now since it is there like this, principle of maximum utility. So so he is asking what is the priority, which road you have to give much priority. So these type of questions, how you are going to attempt it. So for different roads, you have to find out total utility per unit length. Total utility per unit length. Total utility per unit length. For a road, total utility per unit length you have to calculate, and road with maximum utility will be given first preference. Next, road with the minimum utility will be given last preference. So how we are going to calculate this? So for that we have to give factors. So if a population is less than 2000, the impact factor is 0.5, and population is in the range of 2000 to 5000, the factor that you will be using is 1. For more than 5000, factor you will be using is 2. Fine. These are the impact factors that you have to give. That means this will be given more importance and this is given less importance, and this is the length. And here production is not there. If production is there, then you will add production also. Fine. Suppose for road P, total utility per unit length, how you are going to calculate? For road P, total utility per unit length, how you are going to calculate? 8 multiplied with 0.5. Total utility means usage. Fine. 8 multiplied with 0.5 plus 6 multiplied with 1 plus 1 multiplied with 2 plus 6 multiplied with 1 plus 1 multiplied with 2. This is the utility. If there is any production, agricultural production, any production, you should add production also here. That is population. Population will be using the road for traveling, and production means if you are providing any products, you have to move the goods from one place to other place. So if there is anything, you just add it. There is no impact factor for it, or utilization factor, whatever it is. And length given is 20 kilometers divided upon 20. So what is this value? This is for road P. Calculate for road P total utility per unit length. Similarly for road Q. For road Q, what is the total utility per unit length? 19 into 0.5. 19 multiplied with 0.5. 19 multiplied with 0.5 plus 8 multiplied with 1 plus 4 multiplied with 2 plus 8 multiplied with 1 plus 4 multiplied with 2, whole thing upon 28. Whole thing upon 28. This is for road Q. Next, for road R. For road R, similarly you will try to calculate. That is 7 multiplied with 0.5, 5 multiplied with 1, 2 multiplied with 2. 7 multiplied with 0.5 plus 5 multiplied with 1 plus 2 multiplied with 2. Fine. Whole thing upon, what is the length? See, production is not given. Production is 0. Length is 12 kilometers. This is 12. So what is this value? Here what we are trying to find out, we are trying to find out utility per unit length. So for a given length, what is the utility? This is the road used by the passengers and this is the production. Production is 0. Okay. So what is this value for road P? What is total utility per unit length? Please tell me these values. I am not here to calculate. You have to calculate. Make it fast. For road P, what is the total utility per unit length? Why there is delay? For road P it is 0.6. Okay. For road Q, what is the value? For road P 0.6. For road Q, what is the value? For road Q, what is the value? This is approximately 9.5 plus 8 plus 8. 9.5 plus 16. 25.5 upon 28. 25.5 upon 28. 0.91. Yeah, 0.91. And for road R, what is the value? 7 multiplied with 0.5. 3.5 plus 9. 3.5 plus 9. 12.5. It would be more than 1. 1.04. 1.04. So total utility per unit length for different roads are something like this. Since it is like this, the priority first priority will be given for road R, next priority is given for road Q, next priority is given for road P. Fine. So priorities, order of priority if they ask, order of priority if they ask, R, Q, P. This is the order of priority. That means if you are having funds, first you will go for road R, next you will go for road Q, next you will go for road P, because utility is more over there. That is the idea. This is how you will try to solve these type of questions. When they ask what is the utility, I mean what is the which road should be given more priority. These are three roads that is proposed, and which road should be given more priority? Road R should be given more priority compared to that of other roads, P or Q. Next priorities should be given for Q, next priority should be given for P. Fine. So this is one of the problem in this. And what is the other thing that can be asked in the introduction? I think the major one would be 20-year-old plans. There are three 20-year-old plans, right? 20-year-old plans. There are three 20-year-old plans. So name of the plan, first 20-year-old plan, second 20-year-old plan, and third. First 20-year plan, second 20-year plan, and third 20-year plan. Fine. So these are the three plans generally that we will be seeing. And duration 1943 to 1963, and this is 1961 to 1981, and this is 1981 to 2001. These are the three 20-year-old plans. Generally, if you see, that means the plan was 20-year-old plan. It was completed in 61 only. So from 61 it was started once again. This is one of the thing. Okay, this is the duration and location where it took place, location where the meeting took place. So this plans have the another plans, I mean another name. This can also be called as Nagpur plan, Lucknow plan, Lucknow plan, Nagpur plan, not Lucknow, this is Bombay plan. Next one is Lucknow plan, Bombay plan, Lucknow plan, Lucknow plan. Because meeting took place at these places, that is the reason the names are given something like this. Density, density, here it is 16 kilometers per 100 kilometer square area. For every 100 kilometer square area there should be 16 kilometers of road and 32 kilometers per 100 kilometer square area. Next one, here it is 82 kilometers per 100 kilometer square area. This is what you are going to provide. This is density of the roads. That means for a 10 by 10, 10 kilometers by 10 kilometers area, there should be a 16 kilometers of road. Fine. Next, pattern. Pattern of the roads. Pattern of roads. Pattern of roads. Here it is star and grid pattern. Star and grid pattern. Here you will see star and grid and star and circular, a mixture of both the things, and here it would be square and grid pattern. Square and grid pattern. Square and grid pattern. Fine. That means from if you are seeing from the top, it would be star and grid pattern. That would be square and grid pattern. This is pattern of the roads. Next, developmental allowance. Developmental allowance. There would be 15% of development here, developmental allowance. In future development they have seen 5% allowance, nil developmental allowance. That means if it is done, we assume that it is completely fulfilled. This is developmental allowance, star and circle, all the patterns that you can see, developmental allowance. Next, expressways provided. Expressways provided. Here no expressway is provided. Here an expressway of 1600 kilometers is proposed, and here an expressway of 2000 kilometers is proposed. 2000 kilometers of expressway is proposed. Next point, types of roads. Types of roads. Types of roads. Types of roads. So here you will see national highway, state highway, major district roads, other district roads, village roads. Same thing was carried over in second 20-year-old plan, and here it was divided into three types. Primary. Primary is national highways and expressways. Expressways. Secondary. Secondary is state highways, major district roads. Territory is other district roads and village roads. Other district roads and village roads. This is the classification of the roads, type of the roads, or classification of the roads. Classification of the roads. Fine. Classification of the roads. So these are the points that we generally see. Okay. Classification of the roads, type of the roads, primary, secondary, territory. Now, so these are the different types of 20-year-old plans that you have to remember, and other points that you can see in this chapter is types of urban roads. Types of urban roads. In types of urban roads, you will see expressways, expressways, arterial roads, arterial roads, subarterial roads, subarterial roads, collector streets, collector streets, and local streets, collector streets and local streets. These are the different types of urban roads. So we have seen these are the major things that you can see, and lengths of different types of roads as per third 20-year-old plan. Length of the roads as per third 20-year-old plan. Length of the roads as per third 20-year-old plan. As per third 20-year-old plan, length of national highway, length of national highway, NH roads, length of national highway equals to area in kilometers square upon 50 kilometers. Fine. Length of state highway, length of state highway equals to maximum of area in kilometers square upon 25 kilometers, 62.5 times number of towns minus length of national highway, minus length of national highway. This is length of state highway, and length of major district roads, length of major district roads is equals to maximum of area in kilometers square upon 12.5 or 90 times number of towns, 90 times number of towns. This is length of national highways, state highways, and length of other district roads and village roads, or length of other district roads and village roads equals to 4.75 times number of villages and towns, number of villages and towns, or it can be written as density multiplied with area minus length of national highway plus state highway plus MDR. If you subtract it, you will get your answer. Fine. So these are the major things that we will see in introduction to the highways. Any doubts? If you are having any doubts, you can ask me. If not, I will go for the next chapter. Please be fast. Ask whatever the doubts you are having. Any doubts, guys? Any doubts? Please do comment. If you don't comment, any doubts? Anything doubts in this? If not, I'll go for the next concept, next chapter. Sorry, here minus length of national highway plus state highway plus MDR. This is total length of the road. Anyway, there is some mistake. Okay. Soumya, no. Javed, no. Okay. Can I go for the next chapter? Geometric design of highways. If yes, please let me know. We'll go for the next chapter. Geometric design of highway. Please do like, share, subscribe. Can I go for the next chapter? Yeah, okay, fine. One person told me to go for the next chapter and I am going for the next chapter. So please, if you are having any doubts, you can ask me. Okay, next. So geometric design of highways, going with the problems. The first problem that is given to me is the value of camber recommended for CC roads in the area of heavy rainfall is. Value of camber recommended for CC roads in the area of heavy rainfall is. Fine, just a minute. Sorry, there was a call. Okay, so the value of camber recommended for CC roads in area of heavy rainfall is. So camber, what exactly is camber? What exactly is camber? Camber is a cross slope, right? Camber is a cross slope that is provided from which point of view? It is provided from drainage point of view. There can be straight cambers and there can be parabolic camber, right? So this is a straight camber. Generally camber or cross slope is provided from drainage point of view. Camber is provided from drainage point of view. Camber is provided from drainage point of view. Okay, so here this is the cross section I am showing. If the road is like this, I am cutting the road, I am showing you here. This is the cross section of the road. Cross section of the road. Fine. This is straight camber and there can be something called parabolic camber also. This looks exactly like circular, but anyway, this is parabolic camber. Parabolic camber, and there can be mixed one also. Mixed camber would be something like this. At the ends it will be straight, at the center it would be parabolic. If it is parabolic, there will be smooth movement. Smooth overturning operations will be very, very smooth. If it is straight, then overturning operations will be difficult. Fine. So this is straight. This is straight portion. This is straight. And this is parabolic. This is straight and this is parabolic. And generally if you see, I'll say this as 1 in n. If I take this, you can take this as tan theta. Tan theta can also be written as 1 upon n for every this much. And this width would be w upon 2. This will also be w upon 2. And here also, if you see, this height is not going to change. This is y. So generally what you can write is tan theta equals to y upon w by 2, w upon 2, that equals to 1 upon n. Small n, capital N, it will not change. So what I can write over here is our camber 1 in n, or you can say this also as C, anything. Fine. If I take this as some C, camber y equals to CW upon 2. If C is 2%, for example, if they are saying this is 2%, that means that equals to 2 upon 100. For every 100 meters horizontal movement, there will be a vertical rise of 2 meters. That is the idea. This is y equals to c upon 2. And if they ask about parabolic camber, how exactly you are going to see that is something like this. It will also be something like this. Fine. So this distance is w by 2 only. This distance is w upon 2 only, and this is y. And the camber slope approximately it would be c only. Tan theta would be c only. And since this is parabolic, I am saying equation of parabola equals to x square equals to ay. X square equals to ay. So at x equals to w by 2, y equals to cw upon 2. That is not going to change. So w square upon 4 equals to a times cw by 2. So 2 a would be equals to w upon 2c. If I substitute it over here, x square equals to w upon 2c y, or y equals to 2c upon w x square. This is the equation of parabolic camber. Parabolic camber. Equation of parabolic camber. Fine. So we have seen this is the equation of parabolic camber, and this is equation of straight camber. Y equals to cw upon 2. Now for different roads and different types of rainfall, how much camber is to be provided? Type of roads. Type of roads. Type of roads and type of rainfall. Type of roads and type of rainfall. Heavy rainfall, heavy rainfall, less rainfall. Heavy rainfall area, less rainfall area. Fine. So type of roads. So in type of roads, what you can see is cement roads. Cement roads or high bituminous roads. High bituminous roads. Cement roads are high bituminous roads. If it is the region of heavy rainfall, camber provided is 2%, less rainfall 1.7%. Next, this is cement roads or high bituminous roads. Next, thin bituminous roads. Thin bituminous roads. Thin bituminous roads. So in thin bituminous roads, it would be 2.5% or 2%. Fine. And then WBM or gravel roads. WBM or gravel roads, it would be 3% and 2.5%. And finally, earthen roads, earth roads. Earth roads, it would be 4% and 3%. 4% and 3%. Fine. So this table you have to remember. You don't have a choice. If you remember, your problems will be solved easily. So what is the problem that is given to you? The value of camber recommended for CC roads in the area of heavy rainfall. In the area of heavy rainfall, the value of camber recommended for CC roads is how much? In heavy rainfall, for cement concrete roads, the value of camber recommended is 2%. 2% means 1 in 50. 2% is 1 in 50. So your option is D. Your option is D. This is how you have to remember the camber. And generally, camber of shoulder should be steep 0.5% steeper than camber of road, right? How the roads will be generally like, there will be pavement or roadway, and after the road there will be some shoulders. Fine, fine. So if this is the shoulder, this is the shoulder, and this is pavement, carriageway, I'll say this is carriageway, and this is also shoulder. Fine. So camber of shoulder, camber for shoulder should be 5% steeper than camber of shoulder is 5% steeper, 0.5%, not 5%, 0.5% steeper than camber of carriageway, subjected to a minimum of 3%, subjected to a minimum of 3%. Fine. So this is how you're going to provide the camber. Okay, so this is the idea of how you're going to solve these type of problems. Anyway, this is the idea. So you have, if you remember this table, that is enough. This table is enough. So for type of rainfall, for heavy rainfall roads, the camber should be provided as 2%. So your option is D. Fine. Next problem that is given to you is camber on highway pavement is provided to take care of. Your second question, camber on highway pavement is provided to take care of, right? Camber on highway pavement is provided to take care of. It is provided in the highway to take care of what? Drainage. Camber is provided to take care of drainage. Just now I have discussed. That is your second question. Next. The value of lateral friction or side friction used in the design of horizontal curve as per IRC guidelines is. So as per IRC guidelines, what is the value of lateral friction he is asking. So generally there are two types of frictions, longitudinal friction and lateral friction, right? So when a vehicle is moving like this, when a vehicle is going like this, friction acting in this direction, friction acting in this direction is called as longitudinal friction. Longitudinal friction. Generally the value will vary from 0.35 to 0.4. This is longitudinal friction. And friction in this direction into the board. If this is the tire, friction like this is called lateral friction. Friction like this is called longitudinal friction. So the lateral friction, the maximum value for the lateral friction F max equals to 0.15. Longitudinal friction is 0.35 and lateral friction is 0.15. Just you have to remember this. So lateral friction is 0.15. He just asked what is the value of lateral friction. Lateral friction is 0.15. Maximum value as per the guidelines is 0.15 and longitudinal is in the range of 0.35 to 0.4. That is one thing. Next, width of carriageway for single lane is recommended to be. What is the width of the carriageway for single lane? He is asking carriageway, not roadway. So width of carriageway for single lane would be 3.75 meters, right? For dual lane it is 7 meters. 7 meters, right? Width of carriageway is different, roadway is different. Roadway is carriageway plus shoulders. This is carriageway, this is shoulders. So width of carriageway, width for single lane is 3.75 meters. For double lane it would be 7.5 meters, and for multi lanes, if they are asking multi lanes, 3.5 meters per lane. For multi lanes, if they ask, for multi lanes it is 3.5 meters per lane. For multi lanes it is 3.5 meters per lane. That means if they are asking for 4 lanes, 4 times 3.5, 2 lanes, 2 times 3.5. Fine. For double lane with curb, double lane with curb, it is 7.5 meters, and double lane without curb, double lane without curb, double lane without curb equals to 7 meters. Curb stone, you will see that curb stone, generally when there is a road, if there is a footpath, there is a stone, that is called as curb stone. You can see that generally outside. Okay, so these are the points that you have to generally remember. So your option is 3.75 meters. Fine. So this is one of the problem that you will basic problems that we generally see. Next problems related to stopping side distance, stopping side distance, overtaking side distance, intermediate side distance. So the design speed on the road is 60 kilometers per hour. Assuming the driver reaction time of 2.5 seconds and coefficient of friction of the pavement surface as 0.35, the required stopping distance for a two-way traffic on a single lane road is. The required stopping distance for a two-way traffic on a single lane road is. So the design speed on the road is 60 kilometers per hour. This is two-way traffic on a single lane road. This is a single lane road. Always when SSD problem, stopping side distance problem comes to you, you have to go like with basic common sense. Fine. This is a single lane road and two-way traffic. That means both are moving in the same direction. Two-way traffic. Traffic is like this and traffic is like this. Two-way traffic. Now he is asking what is stopping side distance. So what happens is, let us say the person traveling over here has seen this person and applied the brakes. He will come over here and he'll stop. At the same time this person has seen this person, he'll apply the brakes and he'll come over here. Just he has to come and stop. That is called as safe stopping side distance, minimum side distance or stopping side distance, right? So this is, I'll say this as SSD1 and this as SSD2. This is single lane two-way traffic. Single lane two-way traffic. Single lane two-way traffic. Okay. So the total SSD would be equals to, total stopping side distance would be equals to SSD1 plus SSD2. SSD1 plus SSD2. And generally how you are going to find out SSD? SSD would be equals to, stopping side distance would be equals to lag distance plus braking distance. You should know the difference. What is lag distance and what is braking distance? Lag distance and braking distance. Lag distance is based on PIEV theory: perception, intellection, emotion, volition. That means you see the object and then it once it has to reach to your brain, and then your brain has to say apply the brakes, then you will apply the brake. The gap between seeing the object and applying the brake, that is the time period gap. That is also called as reaction time. Generally here it is given as 2.5 seconds. Fine. So lag distance is generally given as V into T. That means in that reaction time period how much distance you have traveled, V into T. And braking distance by applying conservation of energy concept, you will get V square upon 2GF, where F over here is longitudinal friction. F over here is longitudinal friction. So braking distance is V square upon 2GF and lag distance is VT. Okay. Now what is the value of V given to you? Both vehicles are moving with same speed. He has not given different speeds. Both vehicles are moving with the same speed. So V is equals to 60 kilometers per hour. I'll always prefer to convert this. 60 multiplied with 5 upon 18. Instead of remembering, I'll try to convert it. So what is this value? Please let me know. And T equals to 2.5 seconds. So SSD1, that equals to SSD2. So that is VT. VT plus V square upon 2GF. F is given 0.35. Yeah, it is given 0.35. You can take it as 0.35. So substitute this value 60 multiplied with 5 upon 18 multiplied with 2.5 plus 60 multiplied with 5 upon 18 whole square upon 2 multiplied with 9.81 multiplied with 0.35. So what is this value? Please let me know. Stopping side distance. You have seen the value VOM red. What is that, Koda? I don't understand. Will you please elaborate it? So what is this value? What is this value? Please let me know. You have to be fast in the calculations. You have to use Gate Calculator app only. Don't use anything else. Okay? Please use Gate Calculator app. Don't use your scientific calculators. Please do like, share, subscribe with as many people as possible. So SSD1 equals to SSD2 equals to something like this. So what is this value? Please let me know. Only 4 people are watching. Please do like, share, subscribe. What is this value, guys? Make it fast. What is SSD1, SSD2? 60 multiplied with 5 upon 18. You are delaying too much. What is the answer? So Solanki has given the answer as 416.66. I hope that is fine, correct, because I haven't calculated anything. 416.66 meters. He retraced it. See, make it fast, yeah. This is quick. Can't you calculate 60 multiplied with 5 upon 18 multiplied with 2.5? If you are there, please calculate and let me know, so that I can go at faster rate, because even if you want me to do calculations also, that would be quite ridiculous. 81.07. Okay, fine. So this is 81.07, and total SSD would be equals to SSD1 plus SSD2. SSD1 plus SSD2, that is 2 times 81.07 here, that is approximately 162 meters. Let's see whether option is there or not. Yeah, 164.2. It's just an approximation, so it's okay, sorry, fine. So 164.2 meters total. SSD is 164.2 meters. So read that properly. If it is a single lane two-way, then you have to do it like this. Generally it would be SSD is Vt plus V square upon 2GF. Blindly you can go like that, but if it is a single lane two-way road, this is how you will solve it. So this is approximately 164.2 meters. Any doubts in this? You can ask me. Any doubts in this, you can ask me, or we can go for the next problem. Hi sir, good morning. Yeah, good morning Deep Patel 2403. Good morning, very good morning. Any doubts? If you're not having any doubts, next question. So next question is, if design speed is 80 kilometers per hour, perception reaction time is 3 seconds, coefficient of friction is 0.5, then SSD is. Very basic question. See, in gate 1991 it was asked. We don't know whether if at all this type of question is asked, it would be for 1 mark only. So he has given design speed of 80 kilometers per hour. This is a direct question. SSD equals to Vt plus V square upon 2GF. So design speed is 80 kilometers per hour. 80 kilometers per hour. T, time period equals to 0.5 seconds, or reaction time equals to 3 seconds, and coefficient of friction equals to 0.5. 0.5. What is the value of SSD? Just calculate and tell me the answer. Make it fast. 5 upon 18 multiplied with 3 plus 80 multiplied with 5 upon 18 whole square upon 2, 9.81 multiplied with F is 0.5. F is 0.5, right? Not 0.35. See here, whatever the value that is given to you, you have to take. What is the value of SSD you are getting? कितने दे रहे ये session? Till the time you want, I'll be taking the session Solanki. There is, I just have given this day for transportation as people asked for it, students asked for it. So till the time students are present, I'll keep on taking. I'll try to complete the transportation today only, and then you can have. And if you want me to stop somewhere, I'll stop the class. It's up to you. You demand, I supply. So what is the value of SSD? What is the value of SSD? H. Kumar has given answer as B, 117 meters. Is that what you are getting? Please make it fast. You have to be very much fast. I don't know. He has said 117 meters. Is it 117 meters? Another person try to see here. If you do faster, the better thing is this will be an experience for your gate. There also, if you see a simple problem, you should not do any calculation mistakes, and you should give answer in a span of 1 minute. What is the answer, guys? Please. 117 meters. Yeah, Saumya also said the something, so it's fine. Well and good. Question number 6 is completed. Question number 7. Question number 7. A vehicle moving at 60 kilometers per hour. A vehicle moving at 60 kilometers per hour on an ascending gradient. A vehicle moving at 60 kilometers per hour on an ascending gradient of a highway has to come to stop position to avoid collision with the stationary object. The ratio of lag distance to brake distance is 6:5. Considering the total reaction time of the driver as 2.5 seconds, the coefficient of longitudinal resistance as 0.36, the value of ascending gradient. This is an ascending gradient and descending gradient question, right? So here, if vehicle is moving on the ascending gradient, I'm not giving you the proof. I'll directly give you the how you're going to find out lag distance or braking distance. Fine. Vehicle is moving on the ascending gradient. Let us say this is V, this is 0. It has come to stop in order to avoid the collision, and I'll take this as theta. gradient. Theta I'll be taking it as. Fine. So generally SSD if it is moving with ascending gradient, lag distance plus braking distance. Lag distance plus braking distance. Lag distance plus braking distance. Fine. So lag distance would be equals to V into T. Braking distance equals to V square upon 2G multiplied with F plus tan theta. V square upon 2G multiplied with F plus tan theta here. Fine. So it can be given in the terms of percentages or anything. Generally I prefer tan theta. I'll take it like this. If it is moving on the descending gradient, if the vehicle is moving on the descending gradient, if vehicle is moving on the descending gradient, let us say this is V, this is 0. Fine. So SSD would be equals to SSD would be equals to SSD equals to lag distance plus braking distance. Lag distance plus braking distance. Lag distance plus braking distance, that equals to Vt plus V square upon 2G multiplied with F minus tan theta. Vt plus V square upon 2G multiplied with F minus tan theta. This is lag distance, this is braking distance. You should know the difference. And here what he said ascending gradient. Fine. This is ascending gradient. He is asking to find out what is tan theta. And what he has given, lag distance upon braking distance equals to lag distance upon braking distance. Lag distance upon braking distance equals to Vt upon V square upon 2G F plus tan theta equals to, what is the value that is given to you? It is given to you as 6:5. 6:5. 6 upon 5. What is time period that is given to you? Reaction time is 2.5 seconds. Longitudinal friction is 0.36. 2.5. And V is how much? It is moving with a speed of 60 kilometers per hour, right? So this is 60 multiplied with 5 upon 18 upon 2 multiplied with 9.81 multiplied with 0.36 plus tan theta equals to 6 upon 5, that is 1.2. So this is 2.5 times 2 into 9.81 multiplied with 0.36 plus tan theta equals to 1.2 times 60 multiplied with 5 upon 18. So what is the value of tan theta you are getting from here? Please solve it and let me know what is the value of tan theta. Solanki has given some answer, 4.8%. I don't know. Is that what you are getting? Even Kumar is saying the same thing. So it is 4.8 upon 100. This is the value you will get. 4.8 upon 100. That means here you will get 0.048. So 0.048 means 4.8 upon 100 approximate. This you can write it as 4.8 percentage. 4.8 percentage. Okay. 4.8 percentage. This is how you will calculate. Read the question properly, whether it is ascending gradient or descending gradient. If it is ascending gradient, then you will be using F plus tan theta. F plus tan theta. Sometimes this can also be said as G percentage. G percentage, small g percentage, whatever it is. whatever he want to say, g percentage or n percentage, that means indirectly tan theta equals to g upon 100 or n upon 100, whatever they, in different places it is mentioned in different way, so don't get confused by it. So you'll get 0.048. That is how g percentage or n percentage, you'll be asking in terms of percentages, so it would be 4.8 percentage. Tan theta value, if it is 0.048, multiply that by 100, that is the percentage. Simple. Okay, so any doubts in this you can ask me, and if it is descending gradient you will be using f minus tan theta. In ascending gradient you will be using f plus tan theta, in descending gradient you will be using f minus tan theta. Be clear with it. There are proof, I am not giving you the proofs here. Okay, any doubts in this you can ask me. Any doubts, guys? Can I go for the next question? Can I go for the next question? Fine, yeah. So, yeah, this is how you'll solve that. Next question. A car is moving at a speed of 72 kilometers per hour on a road having 2% upward gradient. If the reaction time of the driver is 1.5 seconds and lateral friction is and assuming that f equals to 0.15, he has not specified that as lateral friction. Anyway, whatever the value is given to you, you have to take it. Calculate the distance moved by the vehicle before car stops finally. A car is moving at a speed of 72 kilometers per hour on a 2% upward gradient. Reaction time is 1.5 seconds. F, generally it should be 0.35, but if he has specified 0.15, you will take that and calculate the distance moved by the vehicle before car stops finally. That means indirectly he is asking SSD. SSD for a vehicle moving on ascending gradient. SSD, that equals to Vt plus V square upon 2g f plus tan theta. He said upward gradient. Upward means ascending gradient. V value is 72 kilometers per hour. 72 kilometers per hour. 72 multiplied with 5 upon 18. 18 force. That would be 20 meters per second. And T, reaction time is given to you as 1.5 seconds. And F value is given to us 0.15. Tan theta, he said 2%. That means 2 upon 100, 0.02. Substitute everything and give me the value of SSD. SSD equals to 20 multiplied with 1.5 plus 20 whole square upon 2 times 9.81 multiplied with 0.15 plus 0.02. So what is the value of SSD? Please give me the answer. What is the value of SSD? 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 Please give me the answer. Soumya is saying 150 meters. Everyone is getting the same thing. I don't know. Please cross check it. She is saying 150 meters. 150 meters. 150 meters. Option B. Whatever that is, Soumya, it's okay. 149.5 meters. This is how you'll calculate this. This is moving on an upward gradient. Okay. Yeah. Saurabh Raj is also said the something. Fine. Same thing. Fine. Okay. Next. The next question given to you is coefficient of average rolling friction of a road is Fr. and grade is point coefficient of average rolling friction of a road is Fr and its grade is plus G%. If the grade of the road is doubled, what is the percentage change in the braking distance measured along the horizontal, assuming all other parameters kept constant? So the coefficient of average rolling friction of the road is Fr and its grade is plus G%. If the grade of the road is doubled, what will be the percentage change in the braking distance, he is asking. So he's asking what is the change in the braking distance, not SSD. So what is the percentage change? Please calculate it. What is the percentage change? Problem remains same concept. SSD equals to lag distance plus lag distance plus braking distance. Lag distance plus braking distance. Fine. So braking distance equals to braking distance equals to V square upon 2G multiplied with F plus tan theta. V square upon 2G multiplied with F plus tan theta, that is braking distance. Lag distance plus braking distance, V square upon F plus 2G tan theta. He said plus G%. That means indirectly this is 2G multiplied with F plus 0.01 times G. Okay. Now let us say initially this is the braking distance. Now braking distance is doubled. Braking distance is doubled means B2. The new braking distance would be, or braking, it's not braking distance doubled, the gradient is doubled. Then this is 2G multiplied with F plus 0.02 times G. Why? Because G becomes 2G. This is the new braking distance. So what is the percentage change in the braking distance? He is asking percentage change in braking distance, percentage change in braking distance equals to B1 minus B2 upon B1 multiplied with 100. B1 minus B2 upon B1 multiplied with 100, right? So that would be equals to V square upon, or you can also simply write it as 1 minus B2 upon B1, 1 minus B2 upon B1. Percentage change. So 1 minus, what is B2? B2 is V square upon 2G multiplied with F plus 0.02G upon B1 is V square upon 2G multiplied with F plus 0.01G. V square upon 2G, V square upon 2G gets cancelled. So this would be 1 minus F plus 0.01G upon F plus 0.02G whole multiplied with 100. Whole multiplied with 100. Fine. So this would be equals to F gets cancelled. So this would be equals to 0.01G upon F plus 0.02G multiplied with 100. Percentage change 0.01G upon F plus 0.02G multiplied with 100. This is GATE 2019 question, 3 years back question. Fine. So B1 minus B2, gradient is double. Yeah, exactly. Gradient is double. So G value is now changed to 2G. What he is asking is, what is the difference? What is the percentage change? If you know this, then automatically you can get everything correct. Fine, you should just know what is the braking distance. Braking distance V square upon 2G F plus tan theta. So G value is this. G value, if it gets doubled, what is the value? That is what you will be seeing here. 0.01G upon something like this. Any doubts in this? You can ask me. Any doubts in this, guys? You can ask me. Please do like, share, subscribe. Option is C. Solanki has given the answer. That is the answer. Any doubts in this? you can go ahead and ask me. Any doubts? Any doubts? Please do like, share, subscribe. Any doubts? See, please be fast whenever I'm asking any doubts. Try to comment. Okay? Yeah, no, fine. So, or if you're having any doubts, you can go ahead and ask me. Any doubts, because even the basic doubts I can clear it over here. See, this is a revision session. Please don't expect in-depth. At the same time, as I told you, the person who doesn't know anything, try to understand. Like I'm saying, this is the question, this is the concept, this is the answer. Try to remember that. Your problems will be solved. Simple. Next, for a highway with a design speed of 100 kilometers per hour, the safe overtaking side distance is, assuming acceleration as 0.53 seconds. The safe overtaking side distance is, okay. So for a highway with design speed, the design speed for the highway is given as design speed is given as how much? Design speed is given as 100 kilometers per hour. 100 kilometers per hour. Acceleration due to gravity is how much? Not acceleration due to, its acceleration is given as 0.53 meters per second square. He is asking what is overtaking side distance. Overtaking side distance is generally given as d1 plus d2 plus d3. What exactly is d1 plus d2 plus d3? Let us say this is single lane road, not a double lane road, an undivided highway. Highway is not divided, okay. So this is overtaking vehicle, this is overtaken vehicle. A is overtaking B, okay. A is overtaking B. Let us say A is overtaking B. Now if A is overtaking B, initially it will follow vehicle B, and after that it will overtake. In the meantime, vehicle C should come from here to here, okay, so that there will not be any collision between A and C. So vehicle B is moving, vehicle A overtakes vehicle B, and safely it has to come back to this position, okay, so that there will not be any collision. Fine. And this distance is generally taken as, if I take this as, this is S, this will be B, this will be S. Let us say this is S, this is B, this is S. So before overtaking, what happens is vehicle A will follow vehicle B. Vehicle first, just like think like you are overtaking a vehicle. What you will do first, you will follow that vehicle which has to be overtaken. You follow for 1 or 2 seconds, you follow that, then you'll increase the acceleration, and then you will overtake it. So this whole thing would be d2. d2 would be equals to b plus 2s, and d1 would be equals to vb multiplied with reaction time, or for some time you will follow the vehicle. A will follow B, A will overtake B. In the meantime, A should not collide with C. C moves from that position to this position. This whole distance is called as OSD. This is undivided highway. If it is divided highway, we are not worried about C, because A and B will be moving, there will be a divider, and C will be moving in the other lane. Okay, so if here, since nothing is mentioned, for undivided highway, undivided highway, this is for undivided highway, and for divided highway, OSD equals to D1 plus D2 for divided highway, D1 plus D2 for divided highway, for divided highway. Okay, so these are the points that we generally see. Now D1 equals to VB multiplied with T. VB is equals to speed of overtaken vehicle, speed of overtaken vehicle. That means indirectly that is B, speed of vehicle B. So speed of overtaken vehicle would be equals to design speed minus 16 kilometers per hour. Design speed minus 16 kilometers per hour. That would be equals to 100 minus 16, that equals to 84 kilometers per hour. So this is speed of overtaken vehicle. That means speed of this vehicle. If nothing is mentioned, you will assume something like this. Speed of overtaken vehicle. Speed of overtaking vehicle equals to 100. That means this will be moving, this will be 100, this is 84, or let us say initially we assume that it is moving with this speed only. From here it is, let us say from 84, it would be, if you see here, it will be moving with 100. Anyway, this will be moving with 84 only, and we assume this will be moving with 100. This will also be moving with, this is initially, from finally it will be moving with 100 kilometers per hour speed. Okay, 84, 100. From 84 to 100 it will reach by increasing the acceleration. Fine. Reaction time, since nothing is mentioned, you can assume this small t as 2 seconds. Since nothing is mentioned, you can assume it as 2 seconds. 2 seconds. Okay, this is one thing. And how you are going to find out D2? D2 equals to B plus 2S. B equals to VB multiplied with T. VB multiplied with T. So indirectly this is VB multiplied with T plus half AT square, and S. S is the distance that should be maintained between two vehicles, that equals to 0.7 VB plus L. Since nothing is mentioned, you will take L as 6 meters. So this is 0.7, VB is 84 plus L is 6 meters. 84 multiplied with 5 by 18. Substitute this in meters per second plus 6 meters. You will get the value of S, and half AT square equals to 2S. T would be equals to under root of 4S upon A. You will get the value of T from here. So from here, if you since you know VB and T, you can calculate the value of D2 and D3. D3 would be equals to design speed multiplied with time period. Sir, what is this time period? This is the time period where overtaking operation is done. In the capital T time period, vehicle will be moving from here to here. In the same time period, C has to move from here to here. So it would be 100 kilometers per hour multiplied with that time period. So that value is what you have to calculate. This is 100 multiplied with 5 upon 18 multiplied with T. T you will get from here. Just tell me the values and what is the SSD value. Sorry, OSD value. So first, what is the value of S? Please give me the answer. What is the value of S? 0.7 times. What is the value of S? What is the value of S? Only 4 people are watching. I think you are getting bored because of the concept. It's okay. It happens. So what is the value of S? Please let me know. What is the value of S? 0.7 times VB plus 6. Since nothing is mentioned, we'll take it like this. What is the value of S, and what is the value of T, and what is the value of D3, and what is the value of D2? b plus 2s. So please give me the answer. What is the value of s? S is 22.33. Whatever you say, 22.33. And what is the value of t? What is the value of t? What is the value of t? T is 12.98 seconds, because a value is given to you 0.53. So this is 12.98, and this value would be 84 multiplied with 5 upon 18 multiplied with 12.98. So just tell me what is the value of D2, what is the value of D3, and D1 would be equals to 84 multiplied with 5 upon 18 multiplied with, since t is not mentioned, you can take it as 2 seconds. What is the value of D1, D2, D3? Please tell me those values directly. D1, D2, D3. Sir, will they ask this question? We don't know. They can ask. You have to be very much clear with the concept of how to solve this. Only 3 people are watching. It's okay. No issues. D1, D2, D3. Please give me the answer. What is the value of D3, D2, D1? Make it fast, guys. Whoever that is present, please give me the answer. What is D3, what is D2, what is D1? What happened, guys? What is D3? Simple calculation, 100 multiplied with 5 upon 18 multiplied with 12.98. What is the value? Please don't waste time, because time is precious now. We can go for the next question, next questions, next questions. And why I am making you to solve? Because you won't do calculation mistakes. The major problem with the people is doing calculation mistakes, unit conversions. So that is the reason I am making you to solve the questions. Okay. So what is the answer? D3, D2, D1. Please give me the answer. What is D3, D2, D1? What is D1, D2, D3? So D3 is 360. Okay. D3 is 360. And what is D2? What is D1? Make it fast. Simple calculations, right? What is D2? What is D1? I think Kumar left. Finn also left, right? You people are not commenting. Kumar is there. He is saying B. I asked what is D2, D1. I am not asking what is B, D. Okay? What is D2, D1? Tell me. What is D2? What is D1? Please tell me. పోతాండావా యాడికి పోతాండావు ఏం పని అబ్బా నీకు బయటికి పోవడానికి ఇప్పుడు క్లాస్లో ఉన్నప్పుడు అక్కడ ఎక్కడ పోతా ఉండకూడదు ఎప్పుడు ఒకే చోట ఉండాలి ఓకే సో D2 is 347.46 347.46 what is D1 what is D1 2 9s are 9 9s 81 9 9s 81 so 9 5s 45 approximately 50 so OSD would be equals to D1 plus D2 plus D3 so that would be 50 plus 350 plus 360 plus 360 so approximately this value would be 710 760 meters near to 760 meters what is nearer to 760 that is 750 meters your option is B 750 meters so idea should be very simple D1 D2 D3 if it is undivided highway D1 plus D2 plus D3 if it is divided highway it is just D1 plus D2 undivided means there is no dividers fine if there is no dividers that means everything is moving in the same lane so there can be this type of collision if it is divided means there is divider vehicles will be moving in this direction there will not be any this collision okay so this is how you will try to find out OSD overtaking sight distance so fine this is how you will try to solve this question next question stopping side distance is the minimum next question is theoretical question stopping side distance is a minimum distance available on a highway which is the stopping side distance is the minimum distance available on a highway which is the option A distance of sufficient length to stop the vehicle without collision obviously stopping side distance means you have to provide sufficient length so that you will stop the vehicle without any collision this is correct distance visible to the driver driving night driving no in the daytime also stopping side distance should be there height of the object above the road surface no distance equal to the height of the driver's eye above the road surface no so it is distance of sufficient length to stop the vehicle without collision direct question so your option is A distance of sufficient length to stop the vehicle without collision distance of sufficient length to stop the vehicle without collision that is stopping sight distance next question next a motorist traveling at a speed of 100 kilometers per hour on a highway needs to take the next exit which has a speed limit of 50 kilometers per hour the section of the roadway before ramp entry has a downgrade of 3% and the coefficient of friction is 0.35. In order to enter the ramp at maximum allowable speed limit, the braking distance from the exit ramp. The braking distance from the exit ramp. So a motorist is traveling at a speed of 100 kilometers per hour on a highway needs to take next exit which has a speed limit of 50 kilometers per hour. The section of the roadway before the ramp entry has a downgrade of 3.3% and a coefficient of friction is 0.35. In order to enter the ramp at maximum allowable speed limit, the braking distance from the exit ramp is. Braking distance from the exit ramp is. So here for these type of questions to solve, you should know the concept and you should know some proofs also. From the basics you have to go. Okay. So here the question is, initially a motorist is traveling at a speed of 100 kilometers per hour. Now he has to enter a ramp, and after that the speed on this should be 50 kilometers per hour. So just here his speed is 100 kilometers per hour. His speed here is 100 kilometers per hour, and speed here should be 50 kilometers per hour. Speed here should be 50 kilometers per hour. Okay. 100, 50, 100, and then this is 50 kilometers per hour. At the same time, what is the down gradient? Down gradient is 3%. Tan theta equals to 0.03. So he is asking what is this braking distance. He is not asking stopping side distance or braking distance. Lag distance. He is just asking what is braking distance. So here you have to go from the basics. Initially the speed is V and finally speed was 0. But here there is V1 and V2. Right? There is a speed V1 and V2. 100, 50. Let us say this is V1 and this is V2. Let us say this is braking distance B. Fine, this is braking distance B. W will be acting like this. W sine theta will be like this. Friction will be in this direction, frictional force. If this is W, this is W cos theta. This one is W sine theta. And this is FW cos theta. FW cos theta. So this is W sine theta like this, W cos theta like this. In this direction, it would be FW cos theta. FW cos theta. So you have to go from the basics based on conservation of energy concept. Based on conservation of energy. Based on conservation of energy. Loss in kinetic energy equals to loss in kinetic energy equals to work done by friction. Work done by friction. Loss in kinetic energy equals to work done by friction. So initially it is half mv1 square minus half mv2 square. This is the loss in kinetic energy. Fine. Loss in kinetic energy, that equals to work done by frictional force. So here it would be, if you see W sin theta is like this, F cos theta it is like this. Fine. So what I can say is F cos theta minus W sin theta, this is the force, multiplied with distance. Distance is B, braking distance. right? So f cos theta minus w sin theta multiplied with b, that is your distance. Fine. Now, so this m can be written as half w upon g v1 square minus v2 square. Generally we will take v2 equals to 0. Fine. And for small values of theta, cos theta is taken as 1, sin theta is taken as tan theta. Okay. For small values, for small values of theta, for small values of theta, cos theta approximately taken as 1, sin theta can be approximately taken as tan theta. So just from this approximation you will be using it, and b value f multiplied with w cos theta, not only f cos theta, f multiplied with w cos theta, cos theta. So this is f multiplied with w gets cancelled. So b equals to v1 square minus v2 square upon 2g multiplied with f minus tan theta. So this value would be equals to 100 kilometers per hour. So 100 kilometers per hour in terms of meters per second, what is the value, you tell me, and what is the value in meters per second? Please tell me the values in meters per second. Substitute it. Tan theta equals to 3%. 3%, that is 0.03. Substitute everything, and f value I think it is given to you 0.35. And tell me what is the value of b. F value is 0.35, 150, z is 9.81. Substitute and tell me the value. So here you should know the concept based on conservation of energy. Loss in kinetic energy equals to work done by friction. Loss in kinetic energy equals to work done upon friction. So Kumar has given answer as 92.32 and Soumya has given 92.1. 92.14, 92.32, whatever it is. Fine. So whatever the answer you are getting, substitute it over here. 92.12, 92.34, whatever that is, 92 meters is your answer. So any doubts in this, please let me know. Please do like, share, subscribe with as many people as possible. Okay. Any doubts? Any doubts, guys? Any doubts in this? If not, we'll move to the next question. If you are not having any doubts, we'll move to the next question. Fine. Next question. You want break, or can I take break at 11 o'clock? You want break, or you want me to take break at 11 o'clock? Please be very much clear. Break now or at 11 o'clock? Only 4 people are watching. The 4 people can comment. 11 a.m. sir. Fine. Well and good. Next. Design rate of super elevation for a horizontal curve of radius 450 meters for mixed traffic condition having speed of 125 kilometers per hour. See, this is design super elevation. Here he is not asking normal super elevation. So if he is asking design rate of super elevation for mixed traffic condition, how exactly you will be using? Design super elevation. Design super elevation for mixed traffic condition. For mixed traffic condition. Mixed traffic condition. This is not normal super elevation. He is asking design super elevation. So design super elevation E equals to V square upon 225 R. It is not 127. You will be using 225 R. Fine. So V square upon 225 R. V is 125 kilometers per hour. Radius is 450 meters. So this is 125 whole square upon 225 multiplied with 450. What is the value you are getting? What is the value you are getting? What is the value of E? V square upon 225 R. What is the value of E? సైడ్ డిస్టెన్స్లో నాన్ యూనిఫామ్ యాక్సలరేషన్ కాన్సెప్ట్ ఇంపార్టెంట్ సార్. అంత ఇంపార్టెంట్ లేదండి, మీరు లైట్ తీసుకోవచ్చు. మీరు దీంట్లో ఇంపార్టెంట్ కాదు. మనం ప్రీవియస్ ఇయర్స్ చూసినప్పుడు ఇట్స్ నాట్ నాన్ యూనిఫామ్ యాక్సలరేషన్, నాన్ యూనిఫామ్ వెలాసిటీ వరకు వెళ్తారు కానీ నాన్ యూనిఫామ్ యాక్సలరేషన్ వరకు వెళ్ళలేరు. డోంట్ వరీ అబౌట్ ఇట్. సో వాట్ ఈస్ ది ఆన్సర్ ఫర్ దిస్? What is the answer? Make it fast. E value. What is the value of E? What is the value of E? బ్రేక్ ఎంతసేపు ఇస్తారండి? ఓ 2-3 గంటలు సరిపోతుందా మీకు? Break will be for 15 minutes. It's like a tea break. Lunch break I'll give you somewhere around, I'm planning to give you half an hour to 1 hour. Next tea break 15 minutes. Next we'll go back to our home. Okay. So what is the value of E? 125 square upon 225 multiplied with 450. 0.154. So this is 0.154. 0.154. What is the maximum value which is greater than E max? E max is generally 0.07 only. So you'll provide E equals to E max equals to 0.07. If they are taking design super elevation, it should not be more than 0.07. 0.07. Fine. So this is how it goes. You don't want break. If you don't want break, your subconscious mind will not be that much clear. You have to take a break. Break is always necessary. So E equals to E max equals to 0.07. Fine. That is one thing. So maximum value of E is 0.07. He said design super elevation. In the examination, please be very cautious. If it is design super elevation, E equals to, you will be using V square upon 225 R. That is for mixed traffic condition, because we are designing for 75% of speed as specified by IRC. That is super elevation. What is super elevation? Raising of outer edge with respect to inner edge to overcome the centrifugal acceleration is super elevation. That is some basic concept. If people doesn't know anything, just like generally on the horizontal curves, you will not provide load like this. You will raise the outer edge with respect to inner edge. Why we are raising outer edge with respect to inner edge? Because to overcome centrifugal force. Fine. There will be a centrifugal force. In order to overcome the centrifugal force, in order to overcome the overturning effect and all those things, we'll be doing that. Fine. So there will be a centrifugal force. So centrifugal force, which is generally mv square upon r. mv square upon r. In order to overcome that centrifugal force, we'll be raising the outer edge with respect to inner edge, majorly to avoid overturning, at the same time to avoid skidding or slipping. Fine. In order to avoid overturning and skidding or slipping, we'll be providing super elevation, raising of outer edge with respect to inner edge. If I take this as some E, this is T, E equals to tan theta approximately, raising of outer edge with respect to inner edge, in order to reduce the effect of super elevation. this is W, this is P. This would be W cos theta, and this would be W sin theta. At the same time, if this is P, this is theta, this would be P cos theta, and this would be P sin theta. Fine, and friction will be in this direction. Friction will be in this direction, frictional force F. All these things you should be knowing. F multiplied with normal force. Normal force is W sin theta, W cos theta plus P sin theta. So all these things, I hope you are knowing this. So raising of outer edge with respect to inner edge to overcome the centrifugal force is considered as super elevation. E is the super elevation. Super elevation or banking. Super elevation or banking, I can say. Fine, super elevation or banking. So generally how we'll get the formula is W sin theta minus P cos theta, or W sin theta plus F times N equals to P cos theta, right? If vehicle has to be in equilibrium, what we can say is W sin theta plus F times N equals to P cos theta, right? And W sin theta F times N equals to W cos theta plus P sin theta equals to P cos theta, right? So if this is P cos theta, W into sin theta plus F cos theta equals to P multiplied with cos theta minus F sin theta. If I take cos theta common from both the sides, I will get tan theta. Sin theta by cos theta is tan theta plus F, P multiplied with 1 minus F tan theta, right? So P equals to mv square upon R. 1 minus tan theta is E. So W times E plus F. Fine. And M equals to W by G. W upon G. W gets cancelled. So E plus F equals to V square upon GR. E plus F upon 1 minus EF. Okay. And these values is very less. So 1 is far greater than E times F, because E max is 7%, for plain terrains and for hilly terrains it is 10%, and F value would be F max equals to 0.15. Lateral friction is 0.15. So this is approximated as E plus F equals to V square upon GR. If you substitute everything, then E plus F equals to V square upon 127 R, where V you will substitute in kilometers per hour, R you will substitute in meters. Fine. E maximum value and F maximum value we have seen. R is the radius of horizontal curve. Radius of horizontal. R is the radius of horizontal curve. Okay. So these are the points. V is the design speed. Fine. So directly substitute this in kilometers per hour, R in meters, you will get the value of E and F. This is how you will get this. Fine. And for mixed traffic condition, design super elevation, E equals to V square upon 225 R. Anything, it should not be more than E max. And E minimum is generally taken as camber. E minimum value is generally taken as camber, C value. C we have already discussed that. Fine. C E minimum is taken as C value. E maximum is something like this. You already know this, but just brushing up the things. Okay. So E plus F equals to V square upon 127 R. You will be using this in majority of the case to get your answers. Fine. So our next problem, we'll go to the next problem. The ruling minimum radius, the ruling minimum radius of horizontal curve of a national highway in plain terrain. The ruling minimum radius of horizontal curve, the ruling minimum radius of horizontal curve of a national highway in plain terrain for ruling design speed of 100 km per hour with E equals to 0.07 and F equals to 0.15 is close to. He is asking what is the ruling minimum radius. Ruling minimum radius, if they are asking, you can just use E value and F value. V value is given to you. How will you calculate? E plus F equals to V square upon 127 R. R he is asking ruling minimum radius. So 127 E plus F. Fine. This is ruling. Ruling means indirectly design. Ruling minimum radius. Okay. So V value is how much? Here you will substitute directly in kilometers per hour. In SSD we will convert that into meters per second. Here we will be substituting in kilometers per hour. So V value is 100 kilometers per hour. 100 square upon 127 E value. E is 0.07 plus 0.15. 0.07 plus 0.15. So what is the value of R? What is the value of R? Please give me the answer. What is the value of R? One person, Hemant, has given 357. If any person that is present over here, please give me the answer. Minimum ruling radius R. You are getting 200. 100 square upon 127 plus 0.22. Minimum ruling radius. Please cross check it. 200 option is not there, I think. 250 is there, 200 is not there. Please do it once again, Soumya. Please do it once again. Please do it once again. 100 square upon 127 multiplied with 0.22. Please do like, share, subscribe with as many people as possible. So what is the value? 357.9. Okay, fine, 357.9. So approximately 360 meters. Your option would be B. Approximately 360 meters. Your option is B. Fine. Your option is B. Yeah, fine. Well and good. Next, question number 15. A road is passing through a hilly area. A road is passing through a hilly area with horizontal curve. Super elevation in hilly area is 1 in 10. So provided is 1 in 10 and coefficient of lateral friction is 0.16. The minimum radius of horizontal curve which the vehicles can negotiate at a vehicle can negotiate safely at a speed of 40 kilometers per hour in meters is. So a road is passing through a hilly area. What he is saying, a road is passing through a hilly area with horizontal curve. Super elevation is 1 in 10. Coefficient of lateral friction is 0.16. The minimum radius of horizontal curve which the vehicles can negotiate safely at a speed of 40 kilometers per hour in meters is. He is asking what is the minimum ruling radius. So same formula, apply the same formula, minimum ruling radius. Here speed is how much? 40 kilometers per hour. 40 kilometers per hour. E is 0.1 and this is 0.16. What is the answer? What is the answer? These type of questions will be given for 1 mark. So you should not waste much time. 1 minute, half a second or 1 minute. Just by looking at the question you should solve. What is the answer, guys? 48.45 meters. 48.45 meters. No options is there. If this is correct, this is the answer. Okay. 48.45 meters. Is it correct? I don't know where people went. It's okay. Fine. So Finn, aren't you there, Finn? You are not commenting. So three people are watching. Me, Soumya, and Kumar. Three people are watching. Fine. Now the equation is correct. So R equals to 48.45 meters. R equals to 48.45 meters. Fine, well and good. Next. At highway stretches where overtaking side distance cannot be provided, it is necessary to incorporate. Suddenly the question came, Javed is there, okay. Suddenly the question came back to OSD once again. Anyway, so if you can't provide overtaking side distance, what you will be provide? You will be providing intermediate side distance. If we can't provide OSD, if we can't provide OSD, then we will provide ISD, intermediate side distance. So ISD would be approximately 2 times SSD, stopping side distance. If we can't provide OSD, then we will provide ISD, intermediate side distance, that is 2 times stopping side distance, at least twice the stopping side distance. If we can't provide OSD, then we will provide ISD, that is at least twice the stopping side distance. At least twice the stopping side distance, okay? This is how we'll solve this. Any doubts in this? Any doubts? So finally it was only 3 people that is watching. So please do like, share, subscribe with as many people as possible. No, okay, fine. Next. The design speed for national highway is 100 kilometers per hour. If the maximum permissible super elevation is 0.1 and coefficient of lateral friction is 0.15, the ruling minimum radius of the horizontal curve on the highway should be. The design speed for the national highway is 100 kilometers per hour. Maximum permissible super elevation is 0.1, lateral friction is 0.15. He is asking what is the minimum radius of horizontal curve on the highway. So how you are going to find this out? E plus F equals to V square upon 127 R. He is asking what is the value of R. R equals to V square upon 127 multiplied with E plus F. So what is the value of V? 100.1.15. So this is 100 square upon 127 multiplied with 0.1 plus 0.15. What is the answer? Please give me the answer. Please give me the answer. $302.8 meters. Everyone getting the same answer? 302.8 meters. There is no option of 302.8. Please cross check it once again. The design speed for national highway is 100 kilometers per hour. Maximum permissible super elevation is 0.1. Coefficient of lateral friction is 0.15. The ruling minimum radius on the horizontal curve 314.9. So 314.9, 315 meters is there. Option is there. Please, that's what I'm constantly saying. Don't do that calculation mistake. 314.9 meters, approximately 315 meters. Don't do these type of calculation mistakes, okay? Please don't repeat it. This is question number 17. Next, question number 18. Super elevation needed for a vehicle traveling at a speed of 60 kilometers per hour on a curve of a radius 128 meters with coefficient of friction 0.15. What is the super elevation needed for a vehicle traveling at a speed of 60 kilometers per hour on a curve of radius 128 meters, coefficient of friction 0.15. So super elevation needed he is asking. So if he is asking super elevation needed, then you will be using E plus F equals to 127 R. It is not design. He is asking super elevation needed. Super elevation needed or required. Super elevation needed or required. Fine. So E plus F is how much? 0.15. F is 0.15 and V is 60 kilometers per hour. 60 square upon 127 R. Radius is 128 meters. What is the value of E? 0.071. 0.071. Is that what you are getting? Just direct application of formula, nothing else. Nothing else there is there 0.071. You know, without solving all these things also you can directly answer this question. How? What is the value of E max? Generally E max will be in the range of, speed is not abnormal, speed is in 100 kilometers, less than 100 kilometers per hour only. So if it is in this range, E value should be 0.07. One option is point, everything else is more than 0.07. So you can remove all these things just by seeing at the question. You can tick D. You don't have to solve only. You don't have to solve. Since speed is within the range, if speed is not in the range, then the question will be different. Since speed is within the range, you can go with it, 0.071. Okay, this is one of the thing. Next, see this question. Okay, a super speedway in New Delhi, has among the highest super elevation of any track on the Indian Grand Prix circuit. These are for races. For races, super elevation will be very high because vehicles will be moving at very high speed. You can see the track requires driver to negotiate turns with radius of 335 meters. And 33 degrees banking. That means super elevation is tan 33, which is very, very high. Here speed is also very, very high. Find 320 kilometers per hour is your speed and radius is 335 meters. Very high, all these things. Given this information, the coefficient of side friction required in order to allow the vehicle to travel at 320 kilometers per hour along the curve is. So in order to allow the vehicle to travel at 320 kilometers per hour along the curve with radius of 335 meters and banking, that means tan theta 33 degrees is given to you. What is the side friction he is asking? Just apply your basic formula. E plus F equals to V square upon 127 R. E value is tan 33 degrees. V is 320 kilometers per hour. R equals to 335 meters. V is 320, very much high. R equals to 335 meters. Substitute everything. So tan 33 is how much? I don't know. So you give me the value and tell me what is the value of F. Substitute everything and tell me the value of E and tell me the value of F. Once again, now 10 people are watching. Great. So what is the value of E and what is the value of F? Please give me the answers. What is the value of E and what is the value of F? Please give me the answer. What happened, guys? I am asking what is the value of E, not whether A and all those things. What is the value of E? Tan 33 is how much? Use your gate calculator app. Don't use scientific calculator. please use gate calculator or use your mobile, but don't use this one. E value is how much? Everyone is giving me F value. F value, how much you are getting? 1.75. Okay, 1.75, something like this. What is the value of E? 0.649. Okay, 0.649. Substitute everything. F value you will be getting 1.75. And sir, you said maximum F is 0.15. I said maximum F is 0.15. That is normal road case. This is Indian Grand Prix circuit. That means races will be there. So side friction will be very much high. Super elevation will be very much high because vehicles are moving at very high speeds. It will be, circuit will be something like this. It will be moving like this. So please don't think that here it should be 0.15, so I'll go with 0.176. No, here you have to calculate and solve it. So it's always better to calculate and solve. Okay, your option is A. Next, for a road with camber of 3%, the design speed of 80 kilometers per hour, for a road with camber of 3% and design speed of 80 kilometers per hour, for a road with a camber of 3% and design speed of 80 kilometers per hour, the minimum radius of curve beyond which no super elevation is needed. Here see properly. This is minimum radius of curve beyond which no super elevation is required. Minimum radius of curve beyond which no super elevation is required. So in many places you will be seeing many things, but I feel like the better thing in the examination, if you get, you just go with this. R equals to V square upon 225 E. Generally you take design super elevation, E equals to V square upon 225 R. So R would be equals to V square upon 225 E. And no super elevation is required means it's not that you won't provide super elevation, you will provide E equals to E minimum. That equals to camber. E minimum is how much? That is camber. So R value would be equals to V square. V is how much? 80 kilometer square. 80 square upon 225 E minimum, that is 0.03. So what is the value of R? 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 See, he is saying no super elevation is required, but it's not like E equals to 0. We will get E value, we will do E value as C. So you are getting 948.14 meters. In different booklets you will be seeing different answers, but I feel like this is the better answer, and tomorrow in the GATE examination also go with this, GATE or engineering services. This would be your better answer. 948 meters. GATE also has given this. Some people might be taken V square upon 127 C also, but go with this because he is saying minimum radius of curve beyond which no super elevation is needed. Okay. So don't use all those things. That is the reason, Hemant, I am saying that there are different solutions, but go with this in the examination. If you get the answer, go with this. That's it. Okay. He has not specified anything regarding to there are different explanations, but basic answer would be something like this. These type of questions are like, questionable. That means many people will raise the doubts. So if these type of doubts comes, they'll delete the question, but in the examination, to be on safer side, go with this answer. Many people will raise the question and they'll delete the questions, because uh, sometimes it's like their argument is also right in some cases. Sometimes he'll say, I'll assume f value. If it is not given, why can't I assume f value? Assumptions and all those things, it goes in a different way. Basically you can solve this in this way. Okay, so this is how you'll solve this. 950 meters. Fine. You can assume f value e plus f equals to v square upon 127 r. I'll assume f as 0.15 and then I'll solve. Don't do all those stuff. Okay, go with this. Basically, if they raise the arguments, let them raise, let them delete the question. It doesn't matter if they delete the question or if they don't delete the question, your answer will be correct. Okay, that's how. Be on the safer side. Can I go to the next question? So if they're asking minimum radius beyond which no super elevation is provided, then you'll go with this. If they're asking minimum radius on the horizontal curve, then you'll solve in this fashion. This is minimum radius beyond which no super elevation is required. If they are asking minimum radius, then you will be solving by this formula. Okay, I hope there is no doubt in this. Can we go to the next question? Can we go to the next question? Can we go to the next question, guys? Please let me know. Can we go to the next question? Yeah. So sliding considerations. Sliding consideration for a stopped vehicle on a super elevated horizontal curves provide the following bound on the amount of super elevation. He is asking what is the sliding consideration for a stopped vehicle. For a stopped vehicle to be on the safer side, what is the sliding consideration? E greater than or equal to coefficient of rolling friction, E less than or equal to coefficient of rolling friction, or side friction he is saying. Fine. Rolling friction means a longitudinal friction, side friction means lateral friction. Please be clear with it. Now what he is saying vehicle is stopped. Vehicle is not moving, velocity is 0, vehicle is stopped. If vehicle is stopped, what happens? W will be acting like this, W cos theta will be acting like this, W sin theta will be acting like this. If this is theta, this is W, this is W cos theta, and this is W sin theta, W sin theta. Fine. So vehicle is stopped like this. What happens? It tries to fall like this, because W sin theta is acting like this. It tries to fall. So which will resist this? It is resisted by friction. It is resisted by friction acting in this direction. It is resisted by friction acting in this direction. So this would be F multiplied with N, that is F multiplied with W cos theta. Fine. So if this should not fall, this value should be more. That means for avoiding slippage, for avoiding skidding or slipping of the vehicle, what you have to say, Fw cos theta, this force should be more than this force so that it will not fall. Fine. Fw cos theta should be more than or equal to W sin theta. W gets cancelled. So F should be more than or equal to sin theta by cos theta tan theta. That is E. E should be less than or equal to F. Super elevation should be less than or equal to coefficient of lateral friction or side friction. Okay. Okay. So E should be less than or equal to F. Super elevation should be less than or equal to lateral friction or side friction. So option is D. E should be less than or equal to super elevation or super elevation should be less than or equal to side friction. Side friction or lateral friction. Option is D. Fine. Next question. The same question is being repeated for 3 times. On a circular curve, the rate of superelevation is E. While negotiating the curve, vehicle comes to stop. It is seen that the stopped vehicle does not slide inwards. The coefficient of side friction is F. Which of the following is true? For a side friction, in order to avoid sliding, skidding or slipping, E should be less than or equal to F. 2015, the same question is being asked. Next, a superelevation is provided on a circular horizontal curve. A superelevation is provided on a circular horizontal curve such that a vehicle can be stopped on the curve, without sliding. Vehicle can be stopped on the curve without sliding, assuming a design speed of v and maximum coefficients of side friction as F max. Which one of the following criteria should be satisfied? E should be less than or equal to F max. If vehicle is stopped in order to avoid slipping or skidding or sliding, E should be less than or equal to F max. E should be less than or equal to F max. Okay. Any doubts in this? Please go ahead and ask me. If you are having any doubts, you can ask me in this. Any doubts? Fine. So I think only 2 people are watching. As I said, break is always a required criteria. We'll be taking break for another 15 minutes. I'll be starting class by 11:30 or 11:35. Okay. So stay tuned. Hi friends, am I audible? Gaurav Kumar, can we start the class? Am I audible, visible? Yeah, Gaurav Kumar is there. What about the other guys? H. Kumar, Soumya, Javed, Soumya is also there. Fine. So break is always a necessary thing. It will. It's just I took half an hour break. It's okay. We can uh, do some more extra problems. Okay. Not a big issue. Now, now coming the other type of problems. The design speed for a two-lane road is 80 kilometers per hour with a design vehicle with a wheelbase when a design vehicle with a wheelbase of 6.6 meters is negotiating the horizontal curve on the road. The off tracking is measured as 0.096 meters. The required widening of the carriageway of the two-lane road on the curve is approximately. He is asking what is the extra widening, right? So extra widening, if you how you are going to find out extra widening whenever they are asking extra widening of the curve, mechanical widening, mechanical widening, mechanical widening plus psychological widening plus psychological, mechanical widening plus psychological widening, right? So mechanical widening is generally given as NL square upon 2R, NL square upon 2R. Psychological widening is generally V upon 9.5 times root R. Fine. And L square upon 2R. L square upon 2R is called as off tracking. L square upon 2R is called as off tracking, where L equals to length of wheelbase. L equals to length of wheelbase. If nothing is mentioned, you will take it as 6 meters. If something is mentioned over there, then you will not take any values over here. So L square upon 2R, that is off tracking. L equals to length of wheelbase. This is extra widening. NL square upon 2R plus V upon 9.5 times root R. Now in the question, see properly what is given to you. A design speed for a two-lane road is 80 kilometers per hour. Okay. Length of wheelbase is given to you, so you will be taking it as 6.6 meters. Is negotiating the horizontal curve. Off tracking is measured as 0.096 meters. So L square upon 2R value is 0.096 meters, and it is a two-lane road. Fine. So from here he wants you to calculate what is extra widening. L square upon 2R is given as 0.096. L square upon 2R is 0.096. Fine. L square upon 2R equals to 0.096, and this is 6.6 square upon 2 times 0.096 equals to R. What is the value of R? Radius. What is the value of R that you will get from here? What is the value of R? Please give me the value of R. Now substitute everything. WE NL square upon 2R. N value is given as 2. V you will substitute in kilometers per hour only. R you will substitute in radius in meters only. This is 2 times 0.096 plus this is 80 kilometers per hour. Always remember V you will substitute in kilometers per hour. You will not substitute that in meters per second. 9.5 times whatever the value of R you will get, substitute that it over here and tell me the value of extra widening. R value is 226.875. R value is 226.875. R equals to 226.875. So substitute it over here. What is the value of WE you are getting? Extra widening 0.75 meters. Okay. This is 0.75 meters. This is how we'll try to find out extra widening. The given width is not enough, so we'll be providing an extra width of 0.75 meters to get the answers. Extra widening 0.75 meters. Gaurav Kumar. Yeah. So he solved it. This is the answer. Extra widening is 0.75 meters. Your option is C. Read the question properly, whether they are asking off tracking, whether they are asking mechanical widening. Mechanical widening is NL square upon 2R. L square upon 2R is called as off tracking. So generally extra widening is provided to avoid off tracking. That means path followed by the front wheel is not same as the path followed by the rear wheels. So to overcome this, we'll provide extra widening. And psychologically also, if whenever you're going turning a vehicle, you feel like some extra width is required. So that is psychological widening, and this is extra widening. Fine, no doubts. Okay, we'll go and solve the next question. Next question: a two-lane one-way road, with a radius of 50 meters. A two-lane one-way road with radius of 50 meters is predominantly carrying lorries with wheelbase of 5 meters. The speed of lorries is restricted to be between 60 and 80 kilometers per hour. The mechanical widening and psychological widening required at 60 kilometers per hour are designated as WME 60 and WPS 60 respectively. The mechanical widening and psychological widening at 80 kilometers per hour are designated as WME 80, WPS 80. The correct values of WME 60, WPS 60, WME 80, WPS 80 respectively are. He is asking what is the mechanical widening at 60 kilometers per hour, psychological widening at 60 kilometers per hour, mechanical widening at 80 kilometers per hour, psychological widening at 80 kilometers per hour. So how you are going to find out? At 60 kilometers per hour. Mechanical widening, WME 60, let us say. Mechanical widening is generally given as NL square upon 2R. It is not dependent on speed. So N value, anyway this is two-lane road. That is two-lane road. And length is given as 50 meters. Sorry, length is given as 5 meters, radius is 50 meters. This is a two-lane road. Length of wheelbase 5 meters, radius 50 meters. Right? So 2 times 5 square upon 2 times 50. That is 25 upon 50. That equals to 0.5. This is mechanical widening. And psychological widening at 60 kilometers per hour, V upon 9.5 times root R. So this V value is how much? 60 kilometers per hour. 60 upon 9.5 times root 50. What is this value? You have to say. Next, at 80 kilometers per hour. At 80 kilometers per hour, WME 80. WME 80 equals to NL square upon 2R, 2 times 5 square upon 2 times 50. This will not change. It is not dependent on speed. And WPS 80 equals to V upon 9.5 times root R. V equals to 80 here. 80 upon 9.5 times root 50. So what is this value? Please say these values. These two things will not change. 0.893. 0.893. So this is 0.893. Please do like, share, subscribe with as many people as possible. See, obviously break should be taken after 2 hours. I can go for a class of 4 hours, but this is not concepts that I am discussing, and I am not in a hurry to complete the subject syllabus, right? I am just giving a quick revision. Whatever I will be giving, try to give 100%. So you have to be very much cool. Fine. Don't be in a hurry or don't be something like in this meantime I'll go do that. You just have to be fixed whether you have to sit here, whether you have to leave. Okay. If you are sitting here, sit, take your own time, be cool and enjoy. Fine. So 0.5, 0.89, 0.5, 1.19. Your option would be B. This is a 2 marks question. The idea is question looks very much lengthy, but answer is simple. So this logic is many times when you see this logic, goes good. If question is big, the answer will be in a single liner answer, simple answer. This is one of the thing. Next point. Transition curve is provided in horizontal alignment. Why transition curve is provided generally? Why transition curve is provided? Transition curve is provided in a horizontal alignment. First one is to transition curve is provided between straight curve and circular curve in order to change the radius from infinity to r and from r to infinity, right? Transition curve is provided. Transition curve is provided for changing the radius from infinity to r and from r to infinity right? Transition curve is provided to change the radius from infinity to r and from r to infinity. This is first thing. Infinity will be at the straight and r will be at circular curve. If I take this as the circular curve, this will be transition curve, this will be a straight curve. Similarly, this will be a straight curve. Circular, transitional, straight, circular, transitional curve. Fine. So transition curve is provided. Here the radius is infinity and here radius is r. In order to change the radius from infinity to r and from r to infinity, transition straight, and from r equals to r to r equals to infinity, we'll be providing a transitional curve. This is first thing. Next one is to avoid jerk. Jerk. Fine. Sudden jerk. In order to avoid sudden jerk, you will be providing this. Next, third one, to provide super elevation gradually. And fourth one, to provide extra widening gradually. To provide extra widening gradually. To provide super elevation gradually and to provide extra widening gradually. That means from here E would be 0 to E equals to E. Here also extra widening WE would be equals to WE. In depth I am not giving over here. Here also it would be E equals to E. Here it would be E equals to 0. Fine. E or slope would be something like, it would be perfectly horizontal, and here it would be E. Fine. So this is how it, in order to provide extra widening, in order to provide super elevation, and in order to change the radius from infinity to r, we are going to provide the transitional curves. These are the points that we have to generally remember. Fine. So now, what is the question that is asked? Transition curve is provided in horizontal alignment. To increase the radius of curvature? No, radius of curvature is being decreased. To facilitate the application of super elevation? Yeah, it is correct. To counteract centrifugal force developed? No. To prevent vehicle from skidding laterally? No. This is wrong, this is wrong. So here, this only half part is correct. half part is correct. That means here radius of curvature is decreasing. From here to here radius of curvature is decreasing, here to here radius of curvature is increasing. Only half is correct, half is not correct. But yeah, to facilitate application of super elevation, this is correct. Your option is B. So this is provided to facilitate the application of super elevation. One more. Any doubts in this? You can ask me. Any doubts? Any doubts? Please go ahead and ask me. Even the basic doubts we will discuss. Any doubts? Any doubts, guys? Please do comment. If you don't comment, I can't understand anything. Whoever that is watching, please comment so that I can understand something. Any doubts? No doubts? Fine, at least two people are commenting, no doubts. Next, transition curves are provided on the approach to horizontal curves in order to, so why transition curve is provided? In order to increase the jerk to allowable levels? No, it is provided to reduce the jerk. This is wrong. Minimize the length of horizontal curve? No. Simplify the laying out and construction of horizontal curve? No. The idea is to reduce the jerk to allowable levels. So it is provided in order to reduce the jerk to allowable levels. So option is D. Fine. Option is D. Next. A vehicle negotiates a transition curve with uniform speed V if the radius of horizontal curve and allowable jerk are R and J respectively. The minimum length of transition curve is. So if a vehicle negotiates a transition curve with speed V, length of the transition curve based on jerk criteria he is asking. So jerk he has specified as J, I generally give it as some C. Fine. So if it is jerk, they are saying always go with units. Units of jerk would be rate of change of radial acceleration, meter per second cube. Jerk is generally given as rate of change of radial acceleration, meter per second cube, dA upon dt. So dA, that is v square upon r minus 0 upon t. Time period is t. So that would be equals to v square upon r. Time period t would be equals to L upon v, or length of transition curve upon distance upon velocity, length of transition curve upon velocity. That would be equals to v cube upon r ls. This is C. So length of transition curve would be equals to v cube upon rc. Length of transition curve based on jerk criteria. Length of transition curve based on jerk criteria. Length of transition curve based on jerk criteria, and C value or C or J, whatever it is. Sometimes J, sometimes C. Fine, if you are taking it as J, it would be J. If it is taking it as C, it would be C. J. Fine. So jerk J is generally given as 80 upon 75 plus V. 80 upon 75 plus V. Okay. So where V is the V in kilometers per hour, you will provide it. substitute in kilometers per hour, J value should be in the range of 0.5 to 0.8. If you are getting value less than 0.5, you will take it as 0.5. If you are getting value more than 0.8, you will take it as 8. Okay, so any doubts in this, you can ask me. This is the length of transition curve based on jerk criteria, and the length of transition curve based on super elevation criteria. I'll directly give you the formulas. Length of transition curve based on super elevation, length of transition curve based on super elevation. So if it is rotated about center, NEW plus WE upon 2. If it is rotated about center, and if it is rotated about inner edge, then NEW plus WE. If it is rotated about inner edge. If nothing is mentioned, you will assume that it is rotated about center, rotated about inner edge. Next, length of transition curve based on empirical formula. Length of transition curve based on empirical formula. Length of transition curve based on empirical formula. LS would be equals to 2.7 V square upon R. This is for plain terrain, and this is equals to V square upon R for hilly terrain. Okay, and here N value is important. N value is generally taken as 150 for plain terrains, and it is taken as 60 for hilly terrains. It is taken as 60 for hilly terrain. So you have to remember all these things. Maximum of these three criteria is taken as LS. That means if a problem is given to you, what is the length of the transition curve? LS equals to maximum of V cube upon RJ NEW plus WE upon 2 or NEW plus WE 2.7 V square upon R or V square upon R. Here you will substitute V in kilometers per hour, R in meters, because this is empirical formula. Okay, substitution is very much important. Here you will substitute V in kilometers per hour, R in meters. Okay, so this is the idea. And now coming back to the question, he is asking, this is equals to V cube upon RJ, a direct formula question. If you remember the formula, just by looking at the question you can attempt it. V cube upon RJ. Any doubts in this, you can ask me. Sir, ideal shape of summit curve में doubt है sir. Ideal shape of summit curve के लिए मैं discuss करूँगा. अब तक उधर नहीं गया मैंने. I'm just discussing something related to transition curves. Any doubts up to here, guys? You can ask me. Any doubts up to here? Please go ahead and ask. Transition curves, any doubts? Transition curves, any doubts? Please go ahead and ask. There will not be much problem. Please go ahead and ask if you are having any doubts in the transition curve. Any doubts? Can I go to the next question? Yeah, thank you. Fine. Now, next question. While aligning a hill road with ruling gradient of 6%, a horizontal curve of radius 50 meters is encountered. The grade compensation to be provided for this case would be, while aligning a hill road with ruling gradient of 6%, horizontal curve of radius 50 meters is encountered, the grade compensation to be provided for this case is, he's asking what is the grade compensation. So gradient and grade compensation means gradient is vertical slope. Gradient is vertical slope. Fine. So given gradient is 6%. So apart from vertical curves, there is also a horizontal curve here. So there will be grade compensation, right? So grade compensation is generally given as grade compensation is equals to minimum of 75 upon r or 30 plus r upon r, where r is the radius of horizontal curve. What is the radius of horizontal curve given? 50 meters. So 75 upon 50, 1.5, and this is 30 plus 50 upon 50, 80 upon 50, 1.6. Minimum of these two things, that is 1.5%. Grade compensation is 1.5%. Grade compensation equals to 1.5%. So compensated grade equals to gradient minus grade compensation. Gradient minus grade compensation. Compensated grade equals to gradient minus grade compensation, that equals to 6 minus 1.5%, that is 4.5%. 4.5%, and generally it should not be less than 4%. If it is less than 4%, you will provide a minimum gradient of 4%, right? So this is how you will do grade compensation thing. Why, sir? Why we are compensating grade? Why we are reducing grade? Because already you are moving on a gradient. If a horizontal curve is provided, even more restriction will be there. Fine. So in order to avoid that, we'll be providing grade comp. If you are providing horizontal curve, you'll provide a gradient of 4.5%. Instead of 6%, you'll be providing a gradient of 4.5%. Fine. Any doubts in this? You can ask me. Any doubts? Any doubts? Please go ahead and ask me any doubts. Gaurav Kumar has given the answer. Anyway, any doubts in this? 6 minus 1.5, that is 4.5%. No doubts? Okay. Next, important criteria considered in design of summit curves on the highway is. What is the important criteria that should be considered in design of summit curves on highway? In design of summit curves on highway, what is the important criteria that you should consider? So summit curves, valley curves, all these things comes under vertical curves. So whenever I take a summit curve, if vertical intersection point is above the curve, that is called as summit curve. If vertical intersection point is below the curve, then it is considered as valley curve. This is vertical intersection point. This is summit curve. Now, what is the major problem in the summit curve? The major problem in the summit curve is generally, if vehicle is at the topmost point, centrifugal force will be acting like this, weight will be acting like this. Weight will be acting downwards, centrifugal force is acting upwards. Centrifugal force means always away from the center. This is the center, it acts away from the center, and W is acting like this. So on the vehicles, on the wheels, there will not be any pressure. You just feel like some pressure is released. So at summit point, there is huge amount of comfort. If you are having that phobia of heights, then you'll have fear, but at summit point you will not be having any discomfort. There is no problem of discomfort in summit curves. No problem of discomfort in summit curves. So there is no problem of discomfort. No problem of discomfort. No problem of discomfort in the summit curves. Fine. So if there is no problem of discomfort in the summit curves, this is how exactly it will be like this. Now what exactly summit curve is designed for? Summit curve is designed for side distance. Summit curves are designed for side distance. Summit curves are designed for side distance. There is no problem of discomfort, there is no problem of drainage, nothing. It is only designed for side distance. So the best possible curve or the ideal curve for the summit curve is circular curve. Why circular curve? Because on circular curve the distance traveled or stopping side distance for the vehicles is same. Stopping side distance for the vehicles is same. So the ideal curve is circular curve, but since it is difficult to provide and difficult for the calculations, we will be providing square parabola. The ideal curve is circular curve, but the curve that is provided is square parabola. So side distance will be same. If you provide circular curve, the stopping side distance will be same. Why, sir? Because radius is uniform. So SSD. Exactly, they'll see each other, they'll apply the brakes and they'll come and they'll stop. So it is designed for side distance. The major problem is side distance. So that is the reason the ideal curve, ideal shape of summit curve is circular curve. Ideal shape of summit curve is circular curve. Okay, but since but generally provided curve is for calculation purpose, and laying is also simple on the field purpose and laying purpose, but for calculation purpose and laying purpose we provide square parabola. Fine. So there is no problem of discomfort over there. So it is concave downwards and convex upwards. These are the basic points that we generally see. But summit curves are designed for the side distance, and ideal shape of the summit curve is circular curve, but for calculation purpose and laying purpose we will be using square parabola curves. And length of the summit curve. If you ask me, there are two things. If length is more than SSD and length is less than SSD case. So length of summit curve, if length is more than SSD, L equals to ns square upon 2 multiplied with under root of h plus under root of h whole square, where h equals to height of the driver, and small h would be equals to height of object. Generally it is taken as 1.2 meters, this is 0.15 meters. So if this is the case, S would be equals to SSD and length of the curve would be equals to n multiplied with s square upon, if you substitute 1.2 and 0.5, you will get 4.4 meters. 4.4 meters. And if h equals to 1.2 meters and small h is also equals to 1.2 meters, that means two vehicles are coming, then length of the summit curve would be equals to ns square upon 9.6. Read the question properly and directly you will get the answer. Ns square upon 4.4 or ns square upon 9.6. This is length of summit curve. If length is more than side distance, SSD, it can be SSD, it can be OSD, it can be ISD, anything. It can be ISD. Fine. And if length is less than SSD or length is less than side distance, length is less than SSD, OSD or ISD, then L would be equals to 2s minus 2 times under root of h plus under root of h whole square upon n. That is equals to 2s minus 4.4 upon n if h equals to 1.2 meters and small h equals to 0.15 meters, and this is equals to 2s minus 9.6 upon n if h equals to 1.2 meters and small h is also equals to 1.2 meters. These are the criteria that you should be generally worried. Two criteria. If nothing is mentioned, first assume L is more than SSD and go with the answer. If you're getting this, your answer is correct. Final answer, this should be more than SSD. If this is satisfied, your answer is correct. If not, you will go for this. Okay? Directly I am giving you the answers. N. What is N? N is the difference between the slopes. N1 minus N2. Here, that means suppose if I take any example, if this is N1, this is N2, then N would be equals to, this would be total N. So here would be N1 minus of minus N2. So that would be N equal N1 plus N2. This is how you will calculate the slopes. Difference in the slopes. Fine. So this is negative slope, this is positive slope. That's the reason I'll take minus N2. So whatever it is, first you should draw the figure. Once if you draw the figure, automatically you will get your answers. Okay. So any doubts in this? Length of summit curves. You are asking some doubt, Gaurav. I hope your doubt is cleared now. Fine. And you'll go with these type of answers. This is length of summit curves. Any doubts? You can go ahead and ask me. So the major factor considered in design of summit curves is side distance. The major factor that is considered in designing of summit curves is side distance. Okay, fine. Next, given side distance is 120 meters. Given side distance is 120 meters. Height of driver's eye as 1.5 meters. And height of object as 0.15 meters. Grade difference of international gradient is 0.09. The required length of the summit parabolic curve is. Side distance is given to you as 120 meters. And height of driver's eye, height of the object is given to you. So grade difference is 0.09. What is the length of summit parabolic curve? Calculate that. Calculate that. S is given to you as how much? 120 meters. S is given to you as 120 meters. Height of driver's eye. Capital H equals to 1.5 meters. Small h equals to 0.15 meters. Small h equals to 0.15 meters. And grade difference n equals to 0.09. 0.09. And what is the length of summit parabolic curve required? L value. So L, just assume L is more than SSD. First assume L is more than SSD. Find out L, and finally if L is more than SSD, your assumption is correct. So L equals to ns square upon 2 multiplied with under root of h plus under root of h whole square. N is 0.09. S value is 120 square upon 2 multiplied with under root of h. Root h is 1.5 plus root small h is 0.15 whole square. Then what is the value of L? Please give me the answer. What is the value of L? How much you are getting? What is the value of L? Please give me the answer. I am not discussing setback distance because setback distance is not in the gate examination, so I am not discussing that. Okay. What is the answer, guys? What is the value of L? 250 meters. Only Gaurav is commenting. What about the other guys? Please do comment. Once if you comment, I feel like you are you are there, right? So please do comment. 250 meters, and it is more than SSD 120 meters. Assumption is correct. Assumption is correct. Assumption is correct. Assumption is correct. Okay. So 250 meters. Two persons commented. Soumya, what happened? You are not commenting. Gaurav, Kumar, Soumya, Karthik, and the other person I don't know. Finn was not there. I asked him to be there. He is not there. So your option is 250 meters. Any doubts? Next, the ideal form of summit curve. The ideal form of curve for the summit curve is, what is the ideal form of curve for the summit curve? Just now I told you the ideal form of curve for summit curve is circular curve. We provide parabolic, but ideal form is circular curve, right? Your option is C. Your option is C. Fine. Next question that is given to you is, if an ascending gradient of 1 in 50 meets another ascending gradient of 1 in 30, then the deviation angle is. If the ascending gradient of 1 in 50 meets an ascending gradient of 1 in 30, then deviation angle is. He is asking what is the deviation angle. If an ascending gradient of 1 in 50 meets an ascending gradient of 1 in 30, right? So there is an ascending gradient of 1 in 50. Which one is more? 1 in 50 is more or 1 in 30 is more? Let us say n1 is 1 by 50, n2 is 1 by 30. Which one is more? n2 is more than n1, right? n2 is more than n1. So n2 is steeper than n1. That's how you'll draw. Let us say 1 in 50 and another one is 1 in 30. This is 1 in 30 and this one is 1 in 50, right? 1 in 30 and 1 in 50. Now what he is asking, he is asking deviation angle. This would be your deviation angle. This is your, so that's the reason I always ask you to draw. I always ask you to draw. Just don't go blindly. Here 1 in 50 meets 1 in 30. 1 in 30 is more 1 in 50 compared to 1 in 50. So this is your deviation angle. So deviation angle n would be equals to 1 by 30 minus 1 upon 50. So this value would be, how much is that? 1 by 10, 5 minus 3, 2, 2 upon 1 upon 75. N value is 1 upon 75. And what is the type of curve that is formed? If I join these two things, the curve would be something like this. So this is what VIP is, below the curve. Vertical intersection point is below the curve. So this is valley curve. Valley curve. So if you want to find out what is the type of the curve, if you want to find out what is the type of the curve, the best thing to do is draw. Draw the figure and get the answer. Just don't go blindly. Fine. This is 1 in 50. This is 1 in 30. Fine. 1 in 30 is steeper compared to that of 1 in 50. Join that, then you'll come to know what is the curve. Fine. And n value is, here you have to subtract it. This is your n, not this whole thing. This is your n. 1 in 30 minus 1 in 50. This is 1 in 30. Sorry, not this. Sorry, not this. This is your n. This is 1 in 50. 1 in 30 minus 1 in 50. That is your n. Fine. That equals to 1 in 75. Your option is B. 1 in 75. Fine. Now, so now comes the valley curve. A valley curve has a descending gradient of 1 in 40. A valley curve has a descending gradient of 1 in 40, followed by an ascending gradient of 1 in 50. The length of the valley curve required for a design speed of 80 kilometers per hour for comfort condition. So length of the valley curves. Generally valley curves are designed for valley curves are designed for valley curves valley curves are designed for valley curves are designed for first one is headlight side distance criteria. Headlight side distance criteria. Valley curves are designed for headlight side distance criteria. And second one is comfort criteria. Comfort criteria, that means in order to avoid jerk. In order to avoid jerk. In order to avoid jerk. Next one is drainage problems will be there. Drainage criteria, and then aesthetic views and all those things will be there. Fine. So majorly it is designed for headlight side distance and comfort criteria. Okay. So that means if I take any valley curve means if vertical intersection point is below the curve, it is valley curve. If vertical intersection point is above the curve, then it is called as summit curve. Okay. So the major problem comes during the night when vehicle is exactly over here. When vehicle is exactly over here, what exactly is the side distance that you are having? Headlight side distance. Your headlight, it can go up to here, or if there is dim and dip, it can go up to here, right? So you should know what is your height h of the headlight, and this alpha, dipper angle. Alpha is called as dipper angle. This is small h, you can say headlight side distance. Fine. This whole thing, out of this is taken as h, and if this is s, this would be s tan alpha. Fine. Okay. So headlight side distance criteria, you will be taking it. So length of the valley curve based on HSD, length of valley curve, length of valley curve, length of valley curve based on headlight side distance. Length of valley curve based on HSD equals to ns square upon 2 times h plus s tan alpha. H plus s tan alpha. If nothing is mentioned in the question, you will take h equals to 0.75 meters and alpha equals to 1 degree. If you substitute that, ns square upon 1.5 plus 0.035 times s you will get, where s is the side distance, that is headlight side distance. Generally it will be taken approximately equal to SSD only. Fine, don't worry about it. So there is no problem of OSD over there. There will be only problem of HSD. This is length of the valley curve based on HSD. Length of the valley curve based on HSD. N1, N2, if they ask how will you calculate, this would be your N1, this is your N2. So generally N equals to N1 minus N2 you will take. Here it is minus N1 minus N2. This is negative slope. Okay, so minus of N1 plus N2. Fine. You'll be getting N value something like that. H is the height of the headlight. So this is the length of the valley curve based on headlight side distance. Just find out SSD, substitute, you'll get your answer. This when L is more than SSD case. If L is less than SSD, then length would be equals to 2s minus 2 times h plus s tan alpha upon n, that equals to 2s minus 1.5 plus 0.035 times s upon n. Fine. So this is headlight sight distance criteria based on the headlight sight distance. Length of the valley curves. Next, length of the valley curve based on comfort criteria. If they ask length of valley curve based on comfort criteria, length of valley curve based on comfort criteria, length of valley curve based on comfort criteria. So comfort, that means here when vehicle is exactly at the center, when vehicle exactly at the bottom, what happens is weight will be acting downwards, centrifugal force both will be acting downwards only. So you'll feel huge amount of jerk or discomfort. Okay, so that means you'll be going like this, you'll be feeling huge amount of jerk or discomfort. So in order to avoid that, what we'll be providing is, we'll provide two transitional curves. Why? In transition curve there will not be any jerk, right? So now what, in order for comfort criteria, what you will be doing is, you will be providing two transition curves in the valley curve. That means one transition curve, another transition curve without any circular curve in between. This is one transition curve, this is another transition curve, this is another transition curve. Two transition curves without any circular curve in between is considered as length of valley curve based on comfort criteria, that is 2 times LS. 2 times LS. Fine. And the LS is, you will get it something like under root of NV cube upon C. LS you will be getting it, I am not giving you the proof here, so it is generally given as under root of NV cube upon C. Fine. So if you substitute it, then it would be 2 times under root of NV cube upon C. Here C value is generally, if nothing is mentioned, you will be taking it as 0.6 meter per second cube. 0.6 meter per second cube. You'll be V, you will be substituting in meters per second. Finally, you will get the length based on comfort criteria. So final length of valley curve, if they ask, length of valley curve equals to length of valley curve equals to maximum of, based on HSD, headlight side distance criteria, and based on comfort criteria, Okay, fine. Any doubts? Any doubts in this? Only two people are watching, that is, one is me, another one is Gaurav. I don't know about the other guys. It's okay. So these are the criteria. Length of the valley curve, if they ask, based on HSD you will calculate, based on comfort criteria you will calculate, you will try to calculate something like this. Fine. So in the question what is given? Descending gradient of 1 in 40 meets an ascending gradient of 1 in 50. The length of valley curve for a design speed of 80 kilometers per hour for comfort condition he is asking. C value is not given, so since C value is not given, you will take it as 0.6. So 2 times under root of NV cube upon C, and N value equals to descending gradient meets an ascending gradient. So directly you can add 1 by 40 plus 1 upon 50. 1 upon 40 plus 1 upon 50, that equals to 1 upon 10, 9 by 20. So this is 9 upon 200. N value equals to 9 upon 200, 2 times under root of 9 upon 200. And what is the value of V? 80 kilometers per hour. V equals to 80 kilometers per hour. 80 multiplied with 5 upon 18. Get the value in meters per second. Substitute it over here. C is 0.6 whole cube. Whatever the value of V you are getting substituted, and tell me the value of L. Tell me the value of L. What is the value of L? What is the value of L? length of the curve. This is not square root, it's just 2 times square root, 2 times ls. What is the value of L? Length of the curve. What is the value of length of the curve? What is the value of length of the curve? Gaurav has given 58 meters initially only. If Soumya, if you are there, please give me the answer. What is the value of length of the curve? Please do like, share, subscribe. Please to share with as many people as possible. Uh, Please comment what is the value of L you are getting, length. Is it 58 meters? What is the value of V and what is the value of L? Please comment guys. 57.36 meters. Fine. Same as that of Gaurav, that is approximately 58 meters. So length of transition so length of valley curve is 58 meters that you are getting. Fine. Okay. Next. So this is the question that was asked by Soumya. Sir, what there is a question of non-uniform acceleration. So Soumya, I'll show you how to solve for the non-uniform acceleration. Actually, this is your mathematics problem, not your this problem. This is not your transportation problem. This is mathematics, or you can say physics problem. So it's a more mathematical problem. How you are going to solve these type of questions? Fine. So the acceleration time relationship for a vehicle subjected to non-uniform acceleration. The acceleration time relationship for a vehicle subjected to non-uniform acceleration is something like this. That means acceleration is varying with respect to time. A equals to all those things you have to solve that from your basics. A equals to dv upon dt that equals to alpha minus beta v naught multiplied with e power minus beta t. This is non-uniform acceleration. That means acceleration is varying with respect to time. Fine. Next, where v is the speed in meters per second, time is t is the time, and alpha and beta are parameters. V naught is the initial speed. Okay. If the accelerating behavior of the vehicle whose drive intends to overtake a slow moving vehicle ahead. So a vehicle is accelerating and it intend to overtake a slow moving vehicle ahead, and it is described as dv upon dt equals to alpha minus beta v. So same dv upon dt is given as alpha minus beta v. This is speed of overtaking vehicle. Okay. Considering alpha equals to 2 meters per second square, beta is 0.05 second inverse, and dv upon dt equals to 1.3 meters per second square at t equals to 3 seconds. Distance traveled by vehicle in 35 seconds he is asking. What is the distance traveled by the vehicle in 35 seconds? Alpha is how much? 2. Beta is how much? 0.05. dv upon dt equals to 1.3 meters per second square at t equals to at t equals to 35 seconds, not 35 seconds, at t equals to 3 seconds. Fine. What is the distance traveled in 35 seconds, he is asking. What is the distance traveled in 35 seconds? So generally what you can write is v equals to ds by dt, right? V equals to ds upon dt. ds equals to, this is your basic physics. ds equals to v times dt. Fine. He is asking what is the distance traveled in 35 seconds. So if you want to find out the distance traveled in t seconds, distance traveled in t seconds, ds 0 to s, that would be equals to 0 to t v times dt, where t equals to 35 seconds. If you integrate it, then automatically you will get distance traveled in 35 seconds, 0 to 35 v dt, v dt. Fine. And what we know, dv upon dt equals to alpha minus beta v naught into e power minus beta t, that equals to alpha minus beta v, right? That equals to alpha minus beta v. Fine. From this, what would be the value of v? So beta v naught equals to, beta v equals to alpha minus beta v naught multiplied with e power minus beta t alpha minus beta v naught e power minus beta t. Okay, and v would be equals to alpha upon beta minus alpha minus beta v naught e power minus beta t upon beta. This is the value of v. This is the value of v. Fine. So if this is the value of v, substitute s equals to we don't know what is the value of v naught. So first, for that you have to calculate v naught, and we know we can calculate that from this. Substitute it here. That is 1.3 equals to 2 minus 0.05 v naught multiplied with e power minus beta t minus 0.05 into 3. From this you can calculate what is the value of v naught. Calculate the value of v naught. Fine. Once you calculate the value of v naught, you can substitute it here. S equals to integral 0 to 35 alpha by alpha upon beta, alpha minus beta v naught e power minus beta upon beta, right? Whole multiplied with dt. Anyway, beta is constant, so what you can write, alpha by beta multiplied with t, 0 to 35, and this is alpha minus beta v naught, everything is constant, upon beta e power minus beta t upon minus beta, 0 to 35. So substitute everything. Alpha by beta multiplied with t is 35 minus 0, and this is plus, minus into minus plus, alpha minus beta v naught upon beta square e power minus beta into 35 minus e power minus beta into 0. Fine. Alpha value is 2, beta is 0.05 multiplied with 35 plus, this is 2 minus 0.05 v naught, I don't know how much you are getting, just tell me the value, 0.05 square, and e power minus 0.05 into 35 minus e power minus 0.05 into 0, that is indirectly 1. So from this, s value, what is the value of s? Please tell me what is the value of s. What is the value of s? Time consuming problem. Of course it is a time consuming problem, but if you solve this, you will get the first rank. The person who gets the first rank means the person who has solved everything. At the end you will be getting that 5 to 10 minutes of time. At that time you have to solve this. You don't have a choice. At last 5 to 10 minutes, a person who is smart enough, see, generally you can complete the examination by 2.5 hours to 2 hours 45 minutes. Not a big deal. If you have really read everything and if you are comfortable with everything, you can solve. Problems will be of simple nature. By 2.5 hours to 2 hours 40 minutes, up to 80 marks, 85 marks, you will be completing the examination. The rest 15 marks you have to fight at the end. Like these type of problems will be there. At the end, in that 15 marks, you can score maximum 5 to 7 marks. So 90 to 92, 93 will be your first rank. That's how things goes. So what is the value of V naught? Substitute. You have to be fast in calculations. If you're good at calculations, you'll get your rank. That's it. What is V naught? What is the value of V naught? It might be time consuming, as I said. If like suddenly people will see this type of question and they see that no one has discussed me this concept. Is there any concept in that? Is really there any concept in that? I don't see any concept. Your basic physics. There is no much concept in this. There is basic physics in this. So what is the answer? So what is 9.67? V naught. V naught is 9.67. Fine. Substitute this 9.67 here. And what is the value of distance traveled in 35 seconds? Distance traveled in 35 seconds. Solve this. Distance traveled in 35 seconds. Please give me the answer. Distance traveled in 35 seconds. Please give me the answer. Oh, we not okay. Distance traveled in 35 seconds. Gaurav Kumar, where did you go? You thought this is of a waste problem. You don't want to stay here. It's okay. So what is the answer for S? S, what is the answer? Please make it fast. $900.32. Are you sure? I don't know. You just tell me. 900.32. Gaurav is saying 900.32. What about the other guys? 900.32 meters. So, see, I am solving it for you so that you can give the problem and I ask you to solve. Here I am not asking you to solve. Here I am revising the concepts and I am showing you how to solve the questions. That's it. By being fast, okay? Don't think that, sir, you are not giving us time to solve. I am not giving you time to solve. You can solve, or along with me you can solve. If you have done this, then also it's okay. Okay, so fine. Yeah, 900 points something something. You're getting it. So decimal points are also important. Whatever the decimal they want you to round it off, you round it off according to it. Fine. So I think maximum part is covered in geometric design of highways, and all the other problems you can do it. There are many problems, but I think you can do it. From the concepts is already revised, so I think you can do it. Not a bigger issue. Fine. So if you are clear with this, I hope you can solve as many questions as possible. Anyway, let's solve a problem on transition curve, and valley curve. Not a transition curve. We'll do a problem on valley curve. It was gate question only. Anyway, they have not specified over here. Anyway, we'll do a problem on the length of valley curve. Okay. So for a portion of national highway where descending gradient of 1 in 25, for a portion of national highway where descending gradient of 1 in 25 meets an ascending gradient of 1 in 20. If for a portion of national highway wherein descending gradient of 1 in 25 meets an ascending gradient of 1 in 20, a valley curve needs to be designed for a vehicle traveling at 90 kilometers per hour on following condition: headlight side distance equal to the stopping side distance of a level terrain, considering length of valley curve more than SSD, comfort condition with allowable change of centrifugal acceleration is 0.5 meters per second, and reaction time is 2.5 seconds, longitudinal friction is 0.35, height of the headlight 0.75 meters, beam angle is 1 degree. Beam angle is 1 degree. Beam angle is 1 degree. That is dipper angle is 1 degree. What is the length of valley curve based on headlight side distance and length of valley curve based on comfort condition? What is the length of valley curve based on headlight side distance and comfort condition? So for a portion of national highway, a descending gradient of 1 in 25 meets an ascending gradient of 1 in 20. A descending gradient of 1 in 25. A descending gradient of 1 in 25 meets an ascending gradient of 1 in 20. A descending gradient of 1 in 25 meets an ascending gradient of 1 in 20. This is 1 upon 20. This is 1 upon 25. Okay. A valley curve is to be designed for a vehicle traveling at 90 kilometers per hour. So vehicle traveling at 90 kilometers per hour. Fine. Reaction time. Reaction time is how much? 2.5 seconds, and F equals to 0.35. Reaction time is 2.5 seconds. F equals to 0.35. Height of headlight is 0.75 meters. Alpha equals to 1 degree. Directly it is given to you. He is asking to find out length of valley curve based on headlight side distance criteria. Length of valley curve based on headlight side distance criteria, and length of valley curve based on comfort criteria also. C value is given to you as 0.5 meter per second cube. C or J, it doesn't matter. Fine. So you just have to solve it. How you will be solving this? Simple. Length of valley curve based on HSD. Length of valley curve. Length of valley curve based on HSD. HSD that equals to SSD. That is given in the question, and they asked you to take L is more than SSD. If not, first you assume this. When L equals to NS square upon, directly you can take 1.5 plus 0.035 S, because H and alpha we already know. S equals to SSD, that equals to VT plus V square upon 2GF. V value is 90 kilometers per hour. 90 multiplied with 5 upon 18 meters per second. Substitute it over here and tell me the value of S. From that calculate the value of L. Length of valley curve based on HSD, and length of valley curve based on comfort condition. Length of valley curve based on comfort condition. Length of valley curve based on comfort condition. So L would be equals to LS, 2 times LS, that is 2 times under root of NV cube upon C. N value how will you calculate? N equals to 1 upon 25 plus 1 upon 20. Right? This whole thing would be your N. 1 upon 25 upon 1 upon N, that is 1 by 5 multiplied with 9 upon 20, that equals to 9 upon 100. Substitute and tell me the value of S and L. Similarly, substitute and tell me the value of S. V substitute in meters per second, that is important. This you'll substitute in 0.5. So what is the length of valley curve based on comfort condition and length of valley curve based on headlight side distance? SSD is 153.51 meters. 153.51. So this is 9 upon 100 multiplied with 153.51 square upon 1.5 plus 0.035 multiplied with 153.51. What is the answer? What is the answer you're getting? What is the answer you're getting, guys? Three 308.6 meters. So this is 308.60 meters. Okay, fine, well and good. Next, based on comfort condition, what is the value? V you have to substitute in meters per second, not in kilometers per hour. That means you will be substituting this value. This value, meters per second, you will substitute in meters per second. 18.5 is 90, right? So this would be 25 meters per second. This is 25 cube. What is the value of L based on comfort condition? 106.06 meters. I don't know, but whatever that guy is saying, I'm going with it. Okay. So people, I just wanted to show how the questions can be asked, and this is a gate question, but based on this is, what is that type of questions? The name is common data questions. In very olden days they were asking this, but right now they are not asking this. So any doubts, guys? If you are having any doubts, please let me know. I think you can easily solve these type of questions without much problems. So if you are having any other doubts in geometric design of highways, please let me know. If you are having any doubts in geometric design of highways, please let me know. If not, I'll move to the traffic. Gaurav, I didn't understood your question. Less camber, not steep. Gaurav, I didn't understand your question. Please. And Kumar is saying something. Less camber, not steep. What is this? Please be clear with the question, guys. I didn't get it. please be clear with it. What is that answer? What is that question? Gentler. What is gentler, yeah? Please, I didn't get your question. Oh, gentle is the camber means, okay, gentle is the camber. Uh, Gentler means, okay, in that way you're saying gentler means it is less camber, not steep. Yeah, exactly. The meaning is simple. You don't have to think much for it. Meaning is simple for that. Gentler is the camber. That is the meaning of it. Any doubts, guys? Can I go to the next chapter, or you want me to discuss anything else in this? I'm not discussing setback distance because that is not at all there in your gate examination. I'm just discussing from gate examination point of view, so please be clear with it. Any doubts? Question 36. See, I just kept it like that. That doesn't mean you'll ask this question. Fine. This is simple question here. A parabolic vertical curve is being designed to join a road of gradient 5% with a road of grade minus 3%. The length of the vertical curve is 400 meters measured along horizontal. The vertical point of curvature is located on the road of grade 5%. The difference in height between the vertical point of curvature and vertical point of intersection is. So this is like, for that you should know the geometry of it. If let us say this is vertical point of curvature, you should know what is vertical point of curvature, vertical point of intersection, vertical point of tangency, and all those things. This is VPI, vertical point of intersection, vertical point of intersection, and this is vertical point of curvature, VPC, vertical point of curvature, and this is vertical point of tangency, vertical point of tangency, vertical point of tangency. With and what is this angle? This angle is 5% and this angle is 3%, right? This is 5% and this one is 3%. And what is the logic here? Always remember, vertical point of intersection will be exactly at the center of, or line gone through joining the vertical point of intersection will be exactly at the center of the curve. If this is 400 meters, then this will be 200 meters, this will be 200 meters. Whether n1 equals to n2 or n1 is not equals to n2, the bisector passing through the VPI divide the curve into two halves. If n1 is equals to n2, it divides the curve into two equal halves. If n1 is not equals to n2, it divides the curve into two halves. Fine. So this will be 200, this will be 200. If this is 200, this is 5%, what would be this height? If let us say this is y, tan theta equals to y upon 200. Y upon 200, that equals to 5 upon 100. 5 upon 100. So y would be equals to 10 meters. So the difference between vertical point of intersection and vertical point of curvature is 10 meters. 10 meters. This is your basic doubt here. Okay, for that, hey Prachi, this is not good morning, Prachi. This is good afternoon. After 2 o'clock, it is afternoon. So it is good afternoon. Okay. Y equals to nx square upon 2l. You don't have to do that much here. Just tan theta equals to y upon 200. That equals to 5%. Y equals to 100. You should know the concept that the bisector passing through the VPI divides the curve into two halves. If n1 equals to n2, it divides into two equal halves. If n1 is not equals to n2, it divides into two halves. That's it. That is, yeah, that for that you should know go in depth. But anyway, since I have not seen any problem in that, I have not discussed it. And gentler than camber means, it is lesser than camber. That is the meaning of it. Gentle means is mild. I mean, it is lesser than value. That's the meaning of it. Okay. And Gaurav, nx square upon 2l, that is the equation of the curve, but you don't need the equation of the curve here. He is asking what is the difference between this and this. Y equals to 10 meters. Any doubts in this, Soumya? Now is it clear? Any doubts in this? And if at all there is any question that you want me to discuss, I'll discuss that question also. If you're having any doubts in geometric design of highway, let me know. I'll give you 5 minutes of time. After this, I'll go to traffic. 5 minutes of time. Whatever you want me to discuss, I'll discuss. If not, I'll go to traffic. See, why I took some amount of time. I know that from morning 9:30 to 1, I took time for this, but it is worth. 2 marks is always worth. Minimum 2 marks you can expect from here. 1 or 2 marks, that is always worth. So that's why I have discussed it. Hopefully, if you are lucky enough, you'll get a repeated question from you. If not, some new question can be seen. Okay, so don't worry about it. If you want me to discuss something, let me know, I'll discuss. If not, I'll go to traffic. Curve resistance not important, na sir. It's not important, but what is there in that? It's not that much, because we are not discussing setback distances, so you don't have to be worried about curve resistance. That's it. R multiplied with 1 minus cos theta. That is curve resistance. That's why I'm asking. It is just a small concept. R multiplied with 1 minus cos theta. That's it. No overturning condition. Gaurav, what is? See, if you're not comfortable in English, you can ask me in Hindi also. If you're of most of Hindi nature, you can ask me in Hindi also. I can understand. Okay. Still, there are 3 minutes of time. You can ask me anything that you want to ask me in geometric design of highways, whatever the doubt you are having. I am taking decent amount of time. I'll take decent amount of time for traffic. I'll take decent amount of time for highway materials also. Okay. So please be clear with everything. We'll take break at 2:30 in that range. We'll take the break. Okay, lunch break. Because I have given break in the morning for half an hour break. नो ओवरटर्निंग कंडीशन क्या होता है? मतलब overturning condition comes, I think you're asking in super elevation criteria, right? So when does overturning occurs? Let us take a vehicle is going like this, and centrifugal force is acting like this, weight is acting like this, right? Centrifugal force is acting like this, weight is acting like this, and this is width B, and I'll call this as some H. This is H, this is B, this is P, this is W. Fine. So generally what happens is, about this point, moment due to this one would be, there will be a clockwise moment of P into H. Fine. And that means it tries to rotate the wheel like this, vehicle like this, and weight tries to resist that. Moment due to weight would be equals to W multiplied with B, if at all I take this as P. Fine. For no overturning, for no overturning, for no overturning, for no overturning, W multiplied with B equals to P multiplied with H, or it should be greater than or equal to P multiplied with H. W multiplied with B should be greater than or equal to P multiplied with H. Then only there will not be any overturning. That means B should be greater than or equal to P by W H. Or if sometimes what they'll say is this whole thing is B, from here to here they'll call this as B. If they are calling this as B, this would be B by 2. So this will be B by 2. So B by 2H should be greater than or equal to, this is mv square upon R upon W. So this is B upon 2H should be greater than or equal to V square upon GR. This is no overturning condition. No overturning condition. Okay. Gaurav, now is it clear to you? No overturning condition. B by 2H should be greater than or equal to V square upon GR. No overturning condition. Fine, Gaurav. If it is clear, I'll start traffic. Traffic, which will be terrific. Yeah. Fine. So, if at all, today, not only I'll say not only evening, till 11th, if you're having any doubts, you can ask me, okay? Not a big issue. Here I'll try to cover whatever that came to my view on my mind. I try to cover that. If you feel like, sir, you want me to discuss something, don't worry, we'll discuss that also. Fine. Next, spot speeds. Spot speeds means instantaneous speed. At that instant, what is the speed? The spot speeds observed at the road section are, spot speeds observed at the road section are 66, 62, 45, 79, 32, 51, 50 something, 56, 60, 53 and 49. The median speed is, answer with 1 decimal accuracy he is saying. What is median speed? So whenever they are asking median speed, fine. So what we can do for mode, median and all those things, that is statistics. So you have to write this in ascending order. What is the speeds that is given to you? 66, 62, 45, 79, 32, 51, 56, 32, 51, 56, 60, 53, 49. 53 and 49. So what you have to do, you have to write this in the ascending order. Ascending order would be 32, 32, 45, 49, 51, 53, 56, 60, 62, 66, 79. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if since it is 10, If it is odd number, we know exactly what comes in the middle, since it is the 1 2 3 4 5 6 7 8 9 10. We don't know exactly what comes in the middle, so we'll keep the first 4 away, last 4 away. Some average of these two things will be your median speed. This is your statistics mathematics problem. Fine. So median speed, since they are asking, there is no much thinking into it. Just write this in the ascending order and average of these two things. If it is an odd number, then exactly if it is 9, 53 would be your answer. Fine. So here your answer median speed would be equals to 53 plus 56 upon 2. That equals to 109 upon 2, 54.5 meters per second. This is your median speed. Any doubts? So no doubts. You have already solved it. So this is your spot speed. This is your not meters per second, kilometer per hour. Kilometer per hour. Kilometer per hour. Fine. Okay. This is simple mathematics. Next, see here this is spot speed, and there is something called space mean speed, time mean speed. What is, how you are going to find out time mean speed? Time mean speed. Time mean speed means time remains constant. Time means speed. Or average speed. In the mean speeds, this is not spot speed. In the mean speed, in the average speed, there will be time mean speed and space mean speed, right? Time mean speed. I'm not talking, that is spot speed, instantaneous speed. This is time mean speed. Time mean speed would Vt would be equals to V1 plus V2 plus V3 plus so on up to Vn upon n. This is time mean speed. Fine. How you got how have you visualized this? If you ask me, this would be like, you know, total distance traveled by total time taken. Fine. This is time mean speed. Space mean speed. Space mean speed. Space mean speed. This would be harmonic mean. Harmonic mean of all the speeds. Harmonic mean of all speeds. Harmonic mean of all speeds. This is arithmetic mean of all speeds. Arithmetic mean of all speeds. Arithmetic mean of all speeds. Space mean speed, if they ask, that is harmonic mean of all speeds. That means if different values are given to you, n upon vs would be equals to 1 upon v1 plus 1 upon v2 plus 1 upon v3, something up to 1 upon vn. That is how you'll try to find out space mean speed. Okay, so space mean speed, time mean speed. I just wanted to say 2 points in this. Okay, this is time mean speed, this is space mean speed. Spot speed. Spot speed means that is instantaneous speed. At that instant, what is the speed? Next, desired lines are drawn based on. Desired lines are drawn based on. Desired lines are drawn based on. Generally, you see the desired lines in origin and destination studies. Origin and destination studies. That means what happens is there is an origin and there is a destination. You have to propose the road between these two things. So there would be many ways. Many ways to propose the road. Fine. So here there are different ways. These are called as desired lines, and if thickness of the desired lines is more, that means more traffic is moving in this direction, or traffic movement is high in this direction. If width or thickness of the desired lines is high, that line will be given first priority. This is called desired line. This is given first priority. First priority. That means it indicates high movement of traffic in this direction. So all these things are called as desired lines. Desired lines. Desired lines. So first priority is given for which thickness is high. For direction in which thickness is high. for direction in which thickness is high, for direction in which thickness is high. Fine. So that means more traffic is in the direction. So origin and destination studies, desired lines are generally seen in origin and destination studies. This is one of the thing. Next, speed and delay studies on a defined traffic section of highway can be conducted by speed and delay studies. Speed and delay studies is generally conducted by moving car method or moving vehicle method. Fine. So moving car method, in the moving car method there will be 4 observers in the moving car method. So the 4 observers will be taking different considerations. From that you will try to find out what is the traffic volume, what is the average time taken by it. Fine. So generally speed and delay studies is done by moving car method. Speed and delay studies is done by moving car method. Fine. Okay. Next, a traffic stream in a particular direction of a 2-lane road. A traffic stream in a particular direction of a 2-lane road moving with a constant speed of 50 kilometers per hour with an average headway of 2.52 seconds. That means time headway is 2.52 seconds. The longitudinal distance between the 2 consecutive vehicles is. He is asking what is the longitudinal distance between 2 consecutive vehicles. A traffic stream in a particular direction of a 2-lane road moving with a constant speed of 50 kilometers per hour with an average time headway of 2.52 seconds. The longitudinal distance between 2 vehicles is. So time headway, space headway. Time headway is time interval. Time interval for crossing a particular section, let us say for crossing particular section, time interval between the 2 vehicles. Time interval taken by the 2 vehicles. If it crosses at 10 or if it crosses at 1, this will cross at 1.2 seconds, let us say. Then the time interval is 2 seconds. Fine. So that is called time headway. So time headway, if time headway is given, time headway t, that is given to you as 2.52 seconds. Anyway, if time headway is given, then traffic volume. Traffic volume is generally given in vehicle per hour. Fine. Number of vehicles traveling in the given time period. That is traffic volume. Fine. So if they are saying time headway is something like this, that means one vehicle is traveling in t time period. If t is the time headway, how many vehicles are moving? One vehicle is crossing the section on an average, one vehicle is crossing the section in 2.5 seconds. That is the meaning of it. So if they say q equals to 1 upon t, this is vehicles per second. But generally volume should be given in vehicle per hour. So q would be equals to traffic volume equals to 3600 upon t vehicles per hour, where q is the traffic volume, q is the traffic volume, t, q is the traffic volume, t is the time headway in seconds, t is the time headway in seconds. Fine. Q is the traffic volume, t is the time headway in seconds. So if time headway is given to you, time headway means time interval between 2 vehicles, or indirectly one vehicle will be traveling in that time interval. Fine. So time headway, if time headway is given, then volume would be equals to 3600 upon t vehicles per hour. Fine. And space headway, that is space between 2 vehicles. If it is s meters, space between 2 vehicles is s meters, then traffic density, traffic density traffic density is generally given as 1 upon s meters. So 1 upon s meters, that equals to 1000 upon s vehicles per kilometer. 1000 upon s in terms of kilometer, this is 1 upon s meter. One vehicle is there in s meters. Space headway is space interval between 2 vehicles. Time headway is time interval between 2 vehicles. Now the relationship between these two things, q equals to kv. This is the basic relationship that we generally use. Fine. Where q equals to 3600 upon t, and this is 1000 upon s multiplied with v. This is mean speed. Okay, this is mean speed, not This is in vehicles per hour, this is in vehicles per kilometer, and this is in kilometers per hour. Okay, if you substitute it, then automatically you'll get it. So, or indirectly what I can write over here is 3.6 times S, or S equals to V multiplied with T upon 3.6 meters. You will get this in meters. V you will substitute in kilometers per hour. Anyway, space headway, 3.6 times space headway equals to time headway and mean speed. Okay, fine. So this is the idea that we generally use. So here in the question, if you see, speed is given as 50 kilometers per hour, time headway is given as 2.52 seconds. Substitute it. So 3.6 times S equals to, this is time headway is given as 2.52 and this is 50. What is the value of S? Directly if you substitute, you will get this in meters. 2.52 into 50 upon 3.6. What is the value? S value? 35 meters. Fine. So this is 35 meters. This is how you will calculate. So you should know what is time headway, what is space headway. Time headway is time interval between two vehicles is considered as time headway. Space between two vehicles is considered as space headway. So S equals to 35 meters. Generally V is the mean speed over there. Any doubts in this? You can ask me. Any doubts? Only 4 people are watching. You went for lunch. I told you I'll be giving lunch at 2 or 2:30, right? So any doubts in this, please go ahead and ask me. No doubts? Fine. Next. So now comes a variety of questions based on this Q equals to KV concept. Simple questions is an easy concept and many questions are there. So you know this relationship Q equals to KV. This is traffic volume, and this is called traffic density, and this is mean speed. Mean speed means average speed, mean speed. Fine. So traffic volume, traffic density, traffic mean speed. Okay, for different vehicles, different conditions. If they ask what is the maximum capacity, if they ask what is the maximum capacity, so there are different models. First model I'll be discussing is linear model. Linear model. Linear model. Linear model means the relationship between V and K is linear. Let us say this is V, this is K. This is V, this is K. If this is V, this is K, it would be something like this. So here V equals to VSF and K equals to KJ. So that means at K equals to K, velocity equals to 0. That means no vehicles are moving. If no vehicles are moving, all vehicles will be in stopped condition, right? If no vehicles are moving, all vehicles will be in stopped condition. That is called as jam density. Jam condition, right? All vehicles are in stopped condition means that is jam condition. No vehicle is moving. All vehicles are in stopped condition, jam condition. Jam condition. So in jam condition, maximum density will be there. Jam condition, maximum density will be there. This is called jam condition. Maximum density will be there where speed equals to 0. Density K would be equals to Kj. That is also called as jam density. Jam density. Jam density. Fine. Now, if K equals to 0, if K equals to 0, K equals to 0 means that means there is no vehicle. Vehicles are coming and going at faster rate. Then V equals to called VSF. That is also called as free mean speed. Free mean speed, where K equals to 0. At K equals to 0, V equals to VSF. Right? So this is the linear model. Linear model. So generally, what I can write, V equals to some AK plus B. I can write this as V equals to some AK plus B. At K equals to Kj, V equals to 0. Right? So if I substitute this, A times Kj plus B. Kj would be equals to minus B by A. At K equals to 0, V equals to VSF. Fine, if I substitute it over here, so this equals to VSF, A times 0 plus B. So B equals to VSF. B equals to VSF. If I substitute it over here, what I'll get? Kj equals to minus VSF upon A. So A equals to minus VSF upon Kj. Anyway, proof is not important. I'm just giving it to you like that. So finally what you can write is V equals to AK plus B and A equals to minus VSF upon Kj multiplied with K plus VSF. So V would be equals to VSF multiplied with 1 minus K upon Kj. Whatever the problem that is given to you, you try to convert it something like this. V equals to VSF 1 minus K upon Kj. Fine. This is the equation. Now if I take Q equals to KV, substitute it over here, K times VSF 1 minus K upon Kj. So this would be equals to VSF multiplied with K minus K square upon Kj. So what we want maximum Q value. If you want maximum Q value, what you have to do? You have to just do dQ upon dk equals to 0. dQ upon dk equals to 0. Differentiate this, you will get VSF multiplied with 1 minus 2K upon Kj equals to 0. So from this, what you will get, K would be equals to, at K equals to Kj upon 2, you will get maximum. Fine. If you substitute K equals to Kj upon 2, you will get V equals to VSF upon 2. So maximum volume or capacity, maximum volume or capacity, maximum volume or capacity if they ask in the examination, that would be equals to, Q max would be equals to at V equals to VSF upon 2, K equals to Kj upon 2. So that is VSF multiplied with Kj upon 4. You will get maximum capacity. So maximum capacity or maximum volume. In the question, if they are asking what is the maximum capacity of the road, maximum volume of the road, if it is linear model. If it is non-linear model, this is how you will try to solve. You use dq upon dk, you will generate a relationship between V and K, you will use dq upon dk and you will get the answer. Fine. So if they ask maximum capacity, VSF multiplied with Kj upon 4. Idea is to find out VSF and Kj. Idea is to just find out what is VSF and what is Kj. Okay. So at V equals to VSF by 2, K equals to Kj by 2, you get maximum volume or capacity. Linear model. Fine. Now, we'll try to solve the questions based on it. So the question given to you is, any doubts in that? You can ask me. 6 people are watching. Any doubts in this? You can ask me. Any doubts in this? If not, we'll try to solve the problems at faster rate. Any doubts, guys? Any doubts? No doubts? Fine. Well and good. Now, the speed density relationship on a single lane road with unidirectional flow is given as 70 minus 0.7 K. The capacity of the road in vehicle per hour he is asking, not per lane. That question also will do, but anyway, he is asking vehicle per hour. So speed density relationship is given to you 70 minus 0.7 times K. What is the capacity of the road he is asking? Capacity means indirectly volume he is asking. Fine. So how you are going to find out? Q equals to KV and V or U, whatever that is, V equals to 70 minus 0.7 times K. You have to convert this into VSF multiplied with 1 minus K upon Kj, right? So what you have to do is take 70 common. If you take 70 out of it, 1 minus 0.7 K upon 70. So this would be equals to 70 multiplied with 1 minus K upon 100. So this is the value of V. So if I equate these two things, how exactly I will get? VSF equals to 70, Kj equals to 100. Fine. So from this, Q max capacity would be equals to VSF multiplied with Kj upon 4. That is 70 multiplied with 100 upon 4. What is this value? 25 into 7. 1750 vehicles per hour. Simple. You just try to convert that into this way, you'll get all your answers. Any doubts? Any doubts? 1750. Simple. Everyone is giving the same answer. 1750 vehicles per hour. Please do like, share, subscribe. vehicles per hour. Fine. Okay. Next question. On an urban road, free mean speed was 70 kilometers per hour. Average spacing between the vehicles under jam condition is 7 meters. The speed flow density equation is something like this. That is linear relationship. Maximum flow per lane for this condition. This is only single lane. He has not mentioned any lanes. So free mean speed is given to you and average spacing between the vehicles is given to you. Average spacing between the vehicles is given to you at jam condition. He is asking what is the value of maximum flow capacity. Free mean speed, how much is the value of free mean speed? 70. VSF, read question properly. He has given free mean speed 70 kilometers per hour. Spacing between the vehicles at jam condition. This is at jam condition. Fine. How you will find Kj then? K equals to kj equals to 1000 upon S vehicles per kilometer. 1000 upon 7 vehicle per kilometer. He is asking capacity or maximum flow. Capacity or maximum flow equals to VSF multiplied with kj upon 4. VSF multiplied with kg upon 4, right? So just substitute it everything. 70 multiplied with 1000 by 7 upon 4. 2500 vehicles per hour. Simple. Very simple. He said that as linear model, that is the reason you will be using this. If it is not linear model, then you will be using other way to solve the question. 2500. See? Simple question. Same question, right? Both are same questions. Fine. Next, speed density relationship of an highway is given as 100 minus 0.5 k. 100 minus 0.5 k. The maximum flow he is asking. Please give me the answer directly. I will not solve this. U equals to 100 minus 0.5 k. So what is Q max? Please give me the answer. Soumya has given 5000. Gaurav has also given 5000. So it is 5000. I think VSF would be equals to 100 and KJ would be equals to 200. So 100 multiplied with 200 by 4. That equals to 5000 vehicles per hour. Fine? Yeah, nice. Next. Average free flow speed and the jam density on a road stretch are 60 kilometers per hour and 120 vehicles per kilometers. For a linear speed density relationship, the maximum flow on the road stretch is. So VSF is given as 60, KJ as 20. He is asking maximum flow. VSF 60, KJ 120. VSF 60, KJ is 120. Q max is direct question. 60 multiplied with 120 upon 4. 1800 vehicles per hour. 1800 vehicles per hour. This is the maximum capacity. The same thing. The speed density relationship in a mid-block section of highway follows green shield model. The linear model is also called as green shield model. Linear model is also called as green shield model. Linear model and green shield model both are same, so don't get confused with it. So they asked linear model, what exactly is that? Linear model and green shield model both are same. So free flow speed is Vj and Vf and jam density is Kj. The maximum flow observed in this section is Vf multiplied with Kj upon 4. Right? Vf multiplied with Kj upon 4. Simple. Vf multiplied with Kj upon 4. Next. For two-lane urban road with one-way traffic has maximum capacity of 1800 vehicles per hour. Okay, this is, see here, a two-lane urban road, a two-lane urban road, a two-lane urban road with one-way traffic has a maximum capacity of 1800 vehicles per hour. Under jam condition, average length occupied by the vehicles is 5 meters. Speed versus density relationship is linear. Speed versus density relationship is what? Speed versus density relationship is linear. For a traffic volume of 100 vehicles per hour, for a traffic volume of 100 vehicles per hour, for a traffic volume of 100 vehicles per hour, the density is how much? See here, it is a two-lane road. Always capacity is given in terms of vehicle per hour per lane. Capacity should be given in terms of vehicle per hour per lane. Okay. Capacity is generally given in terms of vehicle per hour per lane. Okay. Till now we have seen only single lane, so that's why I have not discussed that. So vehicle per hour per lane. So two-lane urban road with one-way traffic has maximum capacity of 1800 vehicles per hour. So Q max equals to 1800 vehicles per hour, but number of lanes is 2 lanes. So actual Q max would be equals to 1800 upon 2 vehicle per hour per lane. So that would be equals to 900 vehicle per hour per lane. This is actual Q max, right? And they are saying linear relationship. So VSF multiplied with Kj upon 4. They have given in the question it is linear relationship. Speed versus density relationship is linear. Under the jam condition, the length occupied by the vehicle is 5 meters. So the Kj would be equals to 1000 upon 5. That is 200 vehicles per kilometer. 200 vehicles per kilometer. So if I substitute it over here, 900 equals to VSF multiplied with 200 upon 4. This is 100. This is 2. So V equals to 18 VSF. Free mean speed equals to 18 kilometers per hour. Free mean speed equals to 18 kilometers per hour. We have calculated free mean speed. We came to know jam density. Now what he is asking, for a traffic volume of, I think this should be 1000, not 100. For a traffic volume of 1000 vehicles per hour, the density is, for a traffic volume of how much? 1000 vehicles per hour. For Q of 1000 vehicles per hour, what is the density that should be, he is asking. 1000 means for per lane if you take, then it is 1000 by 2. So Q equals to what? KV. K times V. So 500 equals to V. V equals to VSF because it is a linear model. 1 minus K upon Kj whole multiplied with K. And VSF is 18. And this is K minus K square upon Kj is 200. It is 200. That equals to 500, right? This is equals to 500. So how can I write this? This is K minus K square upon 200 equals to 500 upon 18. 500 upon 18. So k square minus 200k plus 500 upon 18 multiplied with 200 equals to 0. What is the value of k? Just solve this equation, minus b plus or minus b square minus 4ac under root of 200 square minus 4 into 200 multiplied with 500 upon 18 b square minus 4ac upon 2. So what is the value of k you are getting? Tell me that value. So k you are getting 33.33. Fine. So k you will be getting 33.33 vehicles per kilometer. He said for two lane roads. For two lane k equals to 2 times 33.33. That equals to 66.67 vehicles per kilometer. 66.67 vehicles per kilometer. Simple problem. The thing is, idea of understanding is important. So capacity is always given in terms of vehicle per hour per lane. If it is one lane, if nothing is mentioned, you will take it as one lane. But since it is mentioned, you will be taking this as two lanes road. So since two lanes road, Q max is this, VSF this, KJ is this. So once if you know VSF and KJ, then K value equals to 66.67 vehicles per kilometer. Finally, you'll get K value as this. So 2 times that, this is the value. Everyone is getting the same value, I hope. Gaurav said the answer. What about the other guys? Please give me the answer. If someone else is also getting the same answer, please let me know. So vehicles per kilometer. That is how you solve these type of questions. 67 vehicle per kilometer. Any doubts in this concept? Getting the same answer? Fine. So now we'll take a break. It's 2. Okay, we'll take a break. In the next, we'll try to see Webster's method, try to see different things. Okay, how many minutes you want break? Half an hour, 1 hour? So in between 2:30 to 3 we'll meet. Okay, fine. We'll take the lunch break from 2 to 3. 3 o'clock we'll try to meet and we'll try to solve rest of the problems in traffic, in highway, and then materials, railway, airport. Okay, we'll do that. Any doubts in this till now? Okay, bye. Yeah. Sudeep. Sudeep Kumar Gautam. Good evening. Yeah. Sorry, there was a delay of 10 minutes. I said we start from 3 o'clock, right? It's 3:10 actually. 10 minutes of delay. So, uh, hi friends. So, are you there? As usual, I think 4 people are there. 4 people are watching. You want me to wait for 5 minutes? I said we'll start from 3 o'clock and it's 3:11. I came by 3:09. There is a delay of 9 minutes. So, can we start, guys? Whoever that is there, please do comment. Soumya said yes. What about the other guys? If at all there is anyone, please comment. If it is offline class, I don't have to be worried about comments and all those things, because after lunch automatically students will be there in the class and then we'll take the class and we'll keep on moving on. Anyway, I think today we take 1 hour and half an hour, 1.5 hour break we took, right? Not a big issue. Only one person watching, that is me. No other person is there. Wow, great, yeah. Everyone left. Hello, hi. Everyone left. No one is there. In online, that we have to wait for the students to come. Actually, yeah, there are no students anyway. So yeah, one, two, two. You're there. Okay, fine. So can we start? Can we go ahead? Can we start? Okay, let me. Kumar is there. Yeah, Kumar came. Kumar is there. Only 2 people. Soumya, Kumar, Karthik. 3 people are there. What happened to Gaurav? Gaurav left. Yeah, maybe he might have got bored. Fine. We'll start with this. So we have seen how to find out q equals to, how to solve q equals to kb types of problems and all those things. Now we'll be seeing signal design. Fine. So the only thing that in the signal design that we have to say is, generally we design the signal based on one method that you have to remember constantly is Webster's method. We'll be designing the signals based on Webster's method. Okay. We'll be designing the signal based on Webster's method. Webster's Fine. Optimum cycle length. Optimum cycle length. Optimum cycle length C equals to 1.5 times L plus 5 upon 1 minus y. Y equals to y1 plus y2 plus y3 plus so on up to yn. That equals to actual flow upon saturation flow. Actual flow upon saturation flow. You have to always take critical one. Okay. Actual flow upon saturation flow. S represents saturation flow. V represents actual flow. S represents saturation flow. Saturation flow. Fine. L equals to total lost time. Total lost time. Generally it is, if nothing is mentioned, you will be taking it as 2n plus r, where r equals to all read time. We assume that all read time is lost. Fine. N represents number of phases. N represents number of phases. Number of phases, right? So this is one thing that you have to remember in the optimum cycle length case. And if they ask what is the green time for each phase, so for each phase green time would be equals to g1 equals to y1 by y c0 minus l, where c0 is the optimum cycle length. Cycle length means what? There is green time, amber time, or which is also called as yellow time, and red time. That is the cycle length. Fine. Similarly G2 equals to y2 upon y c0 minus l, right? So if at all I am talking about a cycle, if I am talking about a cycle for anything, so that means there will be green time, amber time, red time, right? So it would be like green A, amber A, red B, green B, red B, green B, amber B. Fine. So green time, this is called green time, this is amber time, this is red time. Fine. So optimum cycle length, and this is effective green time. Effective green time, or and generally effective green time would be equals to green plus amber minus time lost. Time lost. This time lost can be startup time lost, ending time lost, anything. Fine. So startup time lost is like whenever if light turns from yellow to green, it takes for your brain it takes certain time to capture that and to move. Fine. So that is called as startup time loss. Generally it will be around 2 seconds. Fine. So these are the points that you have to generally remember when we are talking about Webster's method. Okay. So next, now, so the question that is given to you is, in a signal design as per IRC, Indian Road Congress specifications, if sum of the ratio of normal flow to saturation flow, sum of the ratio of normal to flow to saturation flow is given as 0.5. Total lost time per cycle is, it is not 410 seconds, it is 10 seconds. Total lost time per cycle is 10 seconds. Then optimum cycle length in seconds is, he is asking what is the optimum cycle length. Please give me the answer. What is the optimum cycle length? Fine. So that means he has given y as 0.5. Directly he has given y as 0.5, L equals to 10. He is asking what is the value of C0. 1.5 times L plus 5 upon 1 minus y. 1.5 times 10 plus 5 upon 1 minus 0.5. 15 plus 5, 20 upon 0.5, 200 upon 5, that equals to 40 seconds. So optimum cycle length is 40 seconds. Simple answer, D. Fine. These questions will be very, very simple, not a bigger issue. You just have to understand. He has asked what is the optimum cycle length. Optimum cycle length equals to 40 seconds. Fine. See, I'll tell you one thing. The major problem with the students in the GATE or engineering services is they feel like we have to read more, we have to read more, we have to read more. You're not here to read. You're not here to get into PhDs or something like that. You're here for what? You're here to just clear the examination, and based on that examination you have to focus on the future. In future, if you go to PhD, then get in deeper into the concepts. If you get the job, then go deeper into that. Okay, the idea is, from examination point of view, you have to attempt this. You should learn the concept, but don't waste your time in unnecessary things. Okay, that is one of the point that I wanted to say. Fine. Next, the flow ratios. The critical flow ratio for a three-phase signal are found to be, the critical flow ratio for a three-phase signal are found to be 0.3, 0.25 and 0.25. The total lost time in the cycle is 10 seconds. Total lost time in the cycle is 10 seconds. Pedestrian crossing at the junction are not significant. The respective green time for the three phases are. So here critical flow ratios y1, y2, y3 is given, lost time is given. He is asking green times for these three phases. So please give me the answer. Y1 equals to how much? 0.3, and y2 equals to 0.25 and y2 equals to 0.25. What is G1, G2, G3? Please give me the answer. H. Kumar has given A as answer. What about the other guys? See, I am giving you time because already that type of problem is being solved. So you can solve it. That's why I have given you time. Make it fast. What is there in this? First try to find out optimum cycle length. That is 1.5 times L plus 5 upon 1 minus Y. L is given to you as 10 seconds, I think, right? Total lost time in the cycle is 10 seconds. 1.5 times 10 plus 5 upon 1 minus Y. Y is 0.3 plus 0.25 plus 0.25, right? So total C naught would be equals to 15 plus 5, that is 20. 20 upon 1 minus 0.8, that is 0.2, that is 100. Cycle length is 100 seconds. So if cycle length is 100 seconds, G1 equals to Y1 upon Y multiplied with C naught minus L. That is 0.3 upon 0.8. C naught is 100 minus 10. So 3 upon 8 multiplied with 90. This is G1. G2 equals to 0.25 upon 0.8 multiplied with 100 minus 10. And G3 is also 0.25 upon 0.8 multiplied with 100 minus 10. So what is the answer for these things? There are only three people. I think me, Kumar and then there are two people only right now, me and Kumar, that's it. So only two people, and if Soumya is there, three people, that's it. Yeah, so what is the value G1, G2, G3 you're getting? 34, 28, 28. 34, 28, 28. 56 plus 34, 90. Fine. Whatever you say, that is the answer. Fine. So just 2 marks. This is a 2 marks question. So please be clear with it. There are not many people. I think they might not be interested. Fine. So we should not be worried much about it. For designing a two-phase for designing a two-phase fixed signal at an intersection having north-south, east-west roads where only straight ahead traffic is permitted, the following data is available. The total lost time per cycle is 12 seconds. Total lost time per cycle, this is not per phase. So L equals to 12 seconds. The cycle length as per Webster's approach. What is the cycle length as per Webster's approach? He is saying design hour flow V, saturation flow S. North, south, east, west is given to you. Total lost time is 12 seconds. What is the cycle length as per Webster's approach? Please give me the answer. Only two people or three people are there. It's okay, no issues. You just solve it. Whoever that is present, try to solve it. visibility, is it clear, guys? Hello. If there is anyone, please comment. I don't understand anything. You are not giving answers, you are not commenting, and I feel like visibility is not clear. Lighting and all those things. Okay, you're there. So what is the answer? 64 you got, 71 you are getting. Acha. So this is where you have to think. North, south, east, west. So whenever you get these type of questions, always you have to design for maximum flow ratios, not flows. Generally it should be flow, but anyway, you have to design for maximum flow ratio. Fine. Design hover flow from north. Let us say 1000 is coming, 1000 from the north, and from south it is how much? 700. North, south, east, west. Fine. So from north you are getting 1000. You are getting 1000, and from south you are getting 700, and from east 900, from west 550, from east 900, from west 550, right? So generally what do we think? If we design for 1000, that is enough for, that means for 1000 if you are getting 50 seconds, in 50 seconds if 1000 vehicles can move, 700 vehicles will also be moving, and in the same 50 seconds if 900 vehicles can move, 550 vehicles can also move. Fine, generally we assume this as critical and this as critical and we'll go with it. But here if you see, saturation flows are different. So what you have to do is, for finding out y1 and y2, that is v1 upon s1 and v2 upon s2. So first of all you should know what is y from here. This is 1000 upon saturation flow is 2500. 2500. What is this value? I think this value is 0.4, right? This is 0.4, and here 700 upon 2500. Anyway, this is less than 0.4, so y1 is 0.4. Okay, y1 is 0.4. Generally you'll take this as critical lane volume, but anyway the thing is critical flow ratio should be more. It's not only v, y should be more. Fine, that is the idea. Next, y2. y2 is 900 upon 3000, 550 upon 3000. 900 upon 3000, 550 upon 3000. You should check these values. Anyway, this is more compared to that of this. So this would be y2. What is this value? y2. y2 is 9 upon 30. So between these two things, you should know which one is more. Why, sir? If you design for this, in the same time period, these vehicles can move. Suppose if you are designing for this and you got 50 seconds. In 50 seconds, if 900 vehicles can move, 550 vehicles can easily move, right? So this is y1, this is y2. 9 upon 30, that is 3 upon 10, that equals to 0.3. This is y2. Fine. Once if you know y1 and y2, next c0. c0 would be equals to 1.5 L plus 5 upon 1 minus y. That is 1.5 L. What is the lost time? Lost time is 12 seconds. 12 plus 5 upon 1 minus y. Y is how much? Y is zero point 0.4 plus 0.3, right? 0.4 plus 0.3. 3 by 2 into 12, 6, 18. 18 plus 5, 23 upon 1 minus zero point 0.7. That is 23 upon 0.3. 230 upon 3. Approximately how much? 3 sevens, 21, 20, 76 point, approximately 77 seconds. 77 seconds. Your option is B. So always you have to check for the thing where Y is more. Fine. That means flow ratio should be more. Y1 and Y2 should be more. Here anyway, if you take these as critical lane volumes, automatically you will get this. At the same time, you have to check Y. That means you have to check the ratio. Out of these two things, this is more. If this was more, then you will be taking Y1 as this. Out of these two things, you have to check which one is more, and if that was more, you will be taking that. Fine? Okay? So any doubts in this, you can ask me. This is optimum cycle length. See, the question I have already given you, right? This is the question. Anyway, any doubts in this, guys? Any doubts? Can I go for the next question? Can I go for the next question? Yeah. So the next question is a three-phase signal system, a three-phase traffic signal at an intersection, a three-phase traffic signal at an intersection is designed for flows shown in the figure below. There are 6 groups of flows identified by the numbers 1 to 6. Among these, 1, 3, 4, 6 are through flows. 2 and 5 are right turning flows. Which one of the phasing scheme is not feasible? He is asking, see, these are the traffics 1, 2, 3, 1, 2, 4, 1, 2, 3, 6. 1, 4, 3, 6 are through traffic, and 2 and 5 is right turning traffic. So these are the different phases. Phases means what? When light turns green, phase 1 means here light turns green, 1 and 4 vehicles are moving. In phase 2, 2 and 5 vehicles will be moving. In phase 3, 3 and 6 direction vehicles will be moving. That is the idea. So in this, he is asking which combination is not feasible. How you are going to check? Use your common sense and tell me the answer. In 2 minutes, tell me the answer. You just, I think question is clear to you, right? You use your common sense and tell me the answer. Which combination is not feasible? Which combination is not feasible? Please give me the answer. So Kumar has given the answer anyway. There are only 4 people, so I can expect one person has given the answer. Fine. Let's use the logic here. Let's use the logic. Phase combination P in phase 1, 1 and 4 are moving. Okay. 1 is moving like this, 4 is moving like this. There is no clashes. Well and good. 2 and 5 are moving like this. There is no clashes. Good. 3 and 6 are moving like this. There is no clashes. Idea is to avoid clashes. So there are no clashes. Fine. With P, I don't have any problem. With P, I don't have any problem. Okay. He's asking which is not feasible, right? Next. With Q, what he's saying, 1 and 2 are moving at the same time. Fine, no issues. 4 and 5 are moving at the same time. No clashes. 3 and 6 are moving at the same time. No clashes. So Q also, no problem. R. During phase 1, 2 and 5 are moving like this. No issues. During phase 2, he said 1, 3. So one vehicle is coming like this, vehicle is coming like this. What happens? There is collision. So there is a problem. Similarly, 4, 6, there will be a collision. So R is the one which is not feasible. Your option is R. So you don't need any rocket science. You don't need any transportation engineering, in-depth concepts for this. This is very basic knowledge, right? So answer is R. That's it. Next. On a specific highway, speed density relationship follows Greenberg's model. Fine. Uh, that is linear model is green shield model. Logarithmic model is Greenberg's model. Logarithmic or exponential model, both are Greenberg's models only, where Vf and Kj are free flow speed and jam density respectively. When the highway is operating at capacity, full capacity, then density obtained as per this model is. That means for maximum capacity, what is the density he is asking? For maximum capacity, what is the density he is asking? So I have given you something. V equals to what here? Vf log Kj by K. Kj by K. Fine. So when these type of questions is asked, you should not get panic. Idea is very simple. Q equals to Kv. So K times Vf log Kj upon K. Q. Fine. So dq upon dk should be equals to 0. If you equate it equals to 0, then automatically you'll get your answer. So differentiate this. That means you'll get with respect to K. So you have to use your mathematics. Kj upon K plus K times Vf 1 upon Kj by K multiplied with Kj multiplied with minus 1 upon K square. That is equals to 0. K square. Fine. That means what you can write over here is Vf log E Kj upon K equals to 1. Kj upon K equals to 1. That means Kj upon K should be equals to E. Ka equals to Kj upon E. At K equals to Kj upon E, you will get maximum flow. Simple. Simple. So for dq by dk equals to 0, if you do that, and this is your simple mathematics, at K equals to Kj upon E, you will get it as 0. Very simple. Any doubts in this? You can ask me. K equals to Kj upon E, it is equals to 0. So your option is D. Your option is D. K equals to Kj upon E, that is equals to 0. At K equals to Kj upon E, you will get maximum flow. Okay? Fine. So next point. Moving car observer method is a procedure to find Moving car observer method is a procedure to find what? By moving car observer method, you will be finding out traffic flow, Q value, and you will be finding out time taken, right? Mean time required or time taken. So your option would be what? Simply A. Direct answer. By using moving car method or ride same moving car method, it is you'll be getting it is speed and delay studies where you'll be getting the value of traffic flow for the system. Fine, that is one thing. Next, two major roads with two lanes each are crossing an urban area to form an uncontrolled section. The number of conflict points when both roads are one way to that and when both roads are two way is. So when the number of conflict points, this is two way roads, right? If it is both are two lane roads and both are two way, then it is 24, right? Number of conflict points is 24. And if it is one way, other is two way, that is 11. Number of lanes, road B, number of lanes, road A two way, road B two way, road A one way or road B two way, or here it can be road B two way and roadway one way. It will not change. Road A one way and road B one way. So if both are two lanes, two lanes, two lanes, three lanes, two lanes, four lanes, three lanes, three lanes, four lanes, four lanes, it is 24, 11, 6. 24, 32, 24, 44, 11, 13, 17, 25, 6, 8, 10, 12, 16. Right? Is it correct? Is it correct, guys? Kumar remembers one thing, that for this one it is 24:11. Something like that. Is it correct, guys? Yes, sir. Fine. So if you remember this table, well and good, you'll get the answer. If you don't remember, then you have to draw the figure and do it. I'm not drawing it. Now it is correct. Fine. So do it. Next. So what he is asking, if it is two way and two way, If it is both two-way, it is 24. If it is both one-way, it is 6. So that means when both roads are one-way, it is 6. 6, and when both roads are two-way, it is 24. 6 upon 24, 0.25. 6 upon 24, it is 0.25. So try to remember the table, then your problems will be solved. Next, the safety within a roundabout and the efficiency of a roundabout can be increased respectively. So whenever we are talking about roundabouts, it's like we came into the rotary. So the within a roundabout, safety within a roundabout and efficiency of the roundabout can be increased respectively by. So how can you increase? The idea is we are talking about roundabouts, whenever we are talking about roundabouts, whenever we are talking about roundabouts, whenever we are talking about roundabouts or any rotary, our idea should be very simple. Less number of vehicles should enter and more number of vehicles should leave. Less number of vehicles should enter and more number of vehicles should leave. So entry radius should be less, and exit radius should be more, because less number of vehicles should enter and more number of vehicles should leave. That is the that should be the number of vehicles entering is equals to number of vehicles leaving, but our idea is the vehicle should come at slower speed and it should leave at faster speed. It should not stay, vehicle should not stay here. It should come at smaller speed and it should go at larger speed. Fine, that is the idea. So less number of vehicles entering means when it try to enter into the rotary, it should slow down. At the same time, like if two vehicles are coming slowly, suddenly once it enters into the rotary, it should leave at faster rate. Fine. So here decreasing the entry radius and increasing the exit radius. Our idea is you have to decrease the entry radius and increase the exit radius so that vehicles comes at slower rate, goes at faster rate. In a other way, less number of vehicles should enter and more number of vehicles should leave. That is the idea. Option is C. Fine. Any doubts in this? You can ask me. Clear? Yeah. Kumar is saying clear. Fine. Next point is a well-designed signal intersection is the one in which so if you are designing a signal system properly, crossing conflicts are increased. No, idea should be crossing conflict should be decreased. Number of conflicts should be decreased. So this is wrong. Total delay is minimized. Yeah. Idea is to minimize the delay. Definitely, that is correct. Cycle time is equals to sum of red times plus green times. There will be amber time also. And you should add green time also. Your option is a well-designed signal system is the one in which total delay is minimized. You have to minimize the delay. Fine, that is the idea. Okay, any doubts in this? Minimize the delay in the sense when vehicle is coming, You should not waste your time over there. It has to leave the intersection as soon as possible. That is the idea. Total delay is to be minimized. Any doubts? Kumar is the one who is messaging. What happened to Soumya? Why you are very much silent? Only 3 people are there. Fine. Next. Okay. Maximum number of vehicles observed in any 5-minute period during the peak hour is 160. If the total flow in the peak hour is 1000 vehicles, the 5-minute peak hour factor rounded off to second decimal is. So, peak hour factor. This is one of a good concept. The total flow in an hour, total flow in an hour is how much that is given to you? 1000 vehicles. Total flow in an hour is how much? 1000 vehicles, right? Total flow in an hour is 1000 vehicles. If total flow in an hour is 1000 vehicles and 5-minute peak hour, 5-minute peak hour, right? 5-minute flow. 5-minute flow is given to you how much? The 5-minute period during the peak hour is flow. Number of vehicles observed in any 5-minute period during the peak hour. During the peak hour, 1000 vehicles are moving, and in any 5-minute, number of vehicles are moving is 160 vehicles. In any 5 minutes, 160 vehicles. He is asking what is 5-minute peak hour factor. 5-minute peak hour factor, right? So how exactly you are going to calculate this? How many vehicles are moving in peak hour? 1000 vehicles. Fine. In 5 minutes, if 160 vehicles are moving, in 1 hour, how many vehicles will be moving? That means in 60 minutes, how many vehicles will be moving? 60. That means it is 12 times 160, right? If they ask in 60 minutes how many vehicles are moving, how will you calculate? 60 multiplied with 160 upon 5. So peak hour factor, if they ask, the actual flow is 1000. Okay, well and good. And 60 minutes peak hour factor. And that means, let us say, in 5 minutes 160 vehicles are moving. In the same way, if 60 minutes, that means in every 5 minutes 160 vehicles are moving. In 60 minutes, how many vehicles will be moving? It is simply 60 upon 5 multiplied with 160. This is actual flow in peak hour upon peak flow in peak hour. So what is this value? What would be this value? Ten upon 1.2 multiplied with 16. What is this value? 0.52. Okay. So this is how you will try to find out peak hour factor. So what exactly this means? See, in 0 to 5, 160 vehicles are moving. In 5 to 10, 160 vehicles are moving. Like that, in up to 55 to 60, 160 vehicles are moving. Let us say this is peak hour flow. This is 5-minute peak hour flow. And what is the actual flow? Actual flow is 1000. And 5-minute peak hour flow is something like this, 12 times 160. So peak hour factor is 1000 upon this value. This is called peak hour factor. Okay, 5-minute peak hour factor. Okay, any doubts in this? You can ask me. 5 people are watching. Who are those 5 people? I don't know. Any doubts, guys? Is there any network issues that I am not getting any comments? Make it fast. Soumya, if you are there, please comment. Kumar, if you are there, please comment. Can I go to the next question or not? Please comment. Next question, sir. Yes, sir. Waiting. So it's Soumya, Karthik, Kumar. Great. What happened to that Finn guy? I don't know. I have to trace his number and then I'll message him. Peak hour factor is used to represent the proportion of peak sub-hourly traffic flow within the peak hour. Okay. If 15-minute sub-hours are considered, then theoretical possible range of peak hour factor will be 15-minute peak hour factor range, possible range he is asking. So let us say peak hour flow range he is asking, right? Peak hour flow. Suppose if there is only one vehicle that is moving, that means actually in 16 minutes one vehicle is moving. Okay, that one vehicle, let us say in any of the 15 minutes, 15 to 30, 30 to 45, 45 to 60, let us say 0 1 0 0. Okay, then what is the peak hour factor that you will write? Peak hour factor 15 would be equals to actual flow is 1 upon 60 by 15 multiplied with one vehicle is moving in 15 minutes. So this would be 1 by 4, that is 0.25. Fine. Maximum value. This is minimum value. What could be the maximum value? Maximum value can be 0 to 15, one vehicle is moving. 15 to 30, one vehicle is moving. Fine. And 30 to 45, one vehicle is moving. 45 to 60, one vehicle is moving. So what is the actual flow now? Actual flow is actual flow is actual flow is 4 vehicles are moving. So peak hour factor 15 would be equals to 4 upon 60 upon 15 multiplied with 1. So that is 4 by 4, that equals to 1. 4 upon 4, that equals to 1. So peak hour factor ranges from 0.25 to 1. Simple. Peak hour factor ranges from 0.25 to 1. Option is C. Fine. Please do like, share, subscribe. Only 3 people are watching. Fine. 0.25 to 1. Next, passenger car unit for car on an urban road is, what is the passenger car unit for a car on urban road? This is 1.0. It would be simply 1. Simple question, right? Passenger car unit for a car on urban road is 1. It is simply 1. Next one is a roundabout is provided. A roundabout is provided. A roundabout is provided. A roundabout is provided with an average entry width of 8.4 meters Width of weaving length is 14 meters. Length of weaving length between the channelizing island is 35 meters. Crossing traffic and total traffic of the weaving section is 1000 PCU per hour and 2000 PCU per hour respectively. Fine. The nearest round capacity of the roundabout is direct question. So capacity of a rotary, roundabout or rotary both mean same. So capacity of a rotary capacity of a rotary capacity of a rotary equals to 280 280 E 280 W multiplied with 1 plus E upon W multiplied with 1 minus P by 3 whole thing upon 1 plus W upon L, right? So entry width that is given to you as 8.4 meters, W is given to you as 14 meters, L is given to you as 35 meters. P is generally crossing or weaving traffic, crossing or weaving traffic upon total traffic, crossing or weaving traffic, whole thing upon total traffic, whole thing upon total traffic, crossing or weaving traffic, whole thing upon total traffic. So this is P that is given to us 1000 upon 2000, that equals to 0.5. Substitute everything and tell me the answer. You have to remember the formula. If you remember the formula, then obviously all the problems is solved. 1 minus 0.5 by 3 whole thing upon 1 plus W by L, 14 upon 35. So what is the answer? Please give me the answer. Capacity of the rotary. That is how you will try to find out the capacity of the rotary. So Kumar said 3700. What about Soumya? I don't know. Kumar is saying that as 3700. What about you? How much you got? How much you got? Please let me know how much you got. Calculation mistake, that is huge value. The options are somewhere around something like this, so 3700 is your option. Don't do calculation mistakes, please don't repeat that. Next, the cumulative arrival and departure curve, the cumulative arrival and departure curve, the cumulative arrival and departure curve of one cycle of an approach lane of a signaled intersection is shown in the adjoining figure. The cycle time is 50 seconds, effective red time is 30 seconds, and effective green time is 20 seconds. What is the average delay? So this is delay studies. This is from the delay studies, the uniform delay or average delay. If they ask uniform delay or average delay, direct formula, uniform delay or average delay equals to C by 2, 1 minus G upon C whole square, whole thing upon 1 minus V by S. 1 minus V upon S, right? So this is cumulative arrival and cumulative departure curve. It is given to you. I think figure is not clear over there. I'll draw it for you. Cumulative arrival rate and cumulative departure rate. This is 0, 30, 50. This is 40. Fine. See, this is red time. This is red time, and this one is green time. Green time. So what happens at an intersection? What happens at an intersection? What happens at an intersection? That means, see, let us say you are going in a vehicle, there is a red light. Already some vehicles will be present. So once it turns red, you'll go and you'll stop. So all the vehicles will keep on coming and it will stopping. Till the red time it is there, up to 30 seconds, all the vehicles will come and it will stop. Okay? All the vehicles will come and it will stop. And once color changes to green, all the vehicles will keep on moving, right? Whatever the vehicles that is present, it keeps on moving. And during green time also, some vehicles will keep on coming, right? That means your color has changed from red to green. Some vehicles will keep on coming. It will come and it will leave the intersection. That means whatever the vehicles is coming in this range, it will come and it will leave the intersection. Fine. So now, if you have to see, this will give vehicle arrival rate. Vehicle arrival rate. Vehicle arrival rate. That means it will give me V. And this will give me vehicle departure rate. Vehicle departure rate. That is saturation flow rate. Saturation flow rate. It will give me S. That is S value is given to me. That means if you see 40 vehicles, 0 to this is vehicles, okay? This is vehicles and this is time. Vehicles, time. 40 vehicles is coming to the intersection in 50 seconds of time, right? 40 vehicles is coming in 50 seconds of time. This is arrival rate. Just see this curve. 40 vehicles is coming in 50 seconds. So what would be vehicle arrival rate? V equals to 40 upon 50. That is 0.8. 40 vehicles is coming in 50 seconds. And all these 40 vehicles is leaving the intersection in 20 seconds. It is not leaving the intersection in 50 seconds. In green time, it will be leaving. You just see this curve. What is the slope of this curve? This is S. This is V. 40 upon 50. Same 40 upon 20. 40 vehicles is leaving the intersection in 20 seconds. 40 upon 20. So this is 2. Uniform delay. And what is the total cycle length? 50. So 50 by 2 minus effective green time is 20 seconds and effective red time is 30 seconds whole square upon 1 minus V by S. V is 0.8 upon 2. So what is this value? 1 minus 0.4 whole square, 25.6 upon 0.6. This is 15 seconds. So uniform delay would be equals to 15 seconds. This is how you have to calculate. You have to remember this. You don't have a choice, but you should know how to find out V and how to find out S. Once if you know how to find out V and S, uniform delay is 15 seconds. Okay. Any doubts in this? You can ask. Uniform delay or average delay. Delay studies these are. Any doubts? Next. He is asking for next. Great. The same question, same type of question. The uniform arrival and uniform service rates indirectly, that is saturation flow rate on an approach road intersections are 20 vehicle per minute and 50 vehicle per minute respectively. For this signal, red time is 30 seconds, effective green time is 30 seconds, cycle length is 30 seconds. Assuming that initially there are no vehicles in the queue, average delay per vehicle in the approach road during the cycle length is. What is the average delay per vehicle during the cycle length? Fine. So the uniform arrival rate, V value is 20 vehicle per minute, S values is 20 vehicle per minute, red time is 30 seconds, green time is 30 seconds, cycle length is 60 seconds. What is the average delay? Apply the formula and get me the answer. Simple. Same formula you have to apply and get me the answer. Only two people are watching. That is me and Kumar. That's it. Soumya left. Why Soumya? Why you left? Or Kumar left? Who left? Why you left? Please let me know why you left. Now three people are watching. You are there 12.5 seconds, 12.5 seconds. Okay. People are saying 12.5 seconds. Let's do it. Uniform delay equals to C by 2 multiplied with 1 minus G upon C whole square minus 1 minus V upon S. What is the value of C? C equals to 60 seconds. 60 upon 2 multiplied with 1 minus G upon C. G is 30 and C is 60. 30 upon 60 whole square minus upon 1 minus, what is the value of V? V is 20, S is 50. 20 upon 50. So what is this value? 1 by 2, that is 30 multiplied with 1 by 4 upon 0.6. 12.5 seconds. Simple. So your option is that is 12.5 seconds. 2019 question it is. Only one person watching, yeah? Fine. So this is how you solve this question. Next, so with this maximum, I think I have tried to cover. Is there any other problems that you want me to cover? If there is anything, please let me know. I'll try to cover. There are some theoretical questions in this that you can do, not a bigger issue. Hello, are you there? So if you are there, try to solve this question. Probability question. I think I haven't touched this thing. Probability that k number of vehicles arrive in time t is given as lambda t to the power of k e power minus lambda t upon k factor. Vehicle arrival rate. Probability distribution or Poisson's distribution. Probability that k, what he is saying? Probability that k vehicles will arrive in t seconds is equals to lambda t whole to the power of k, lambda t whole to the power of k e power minus lambda t upon k factorial. Find probability that k vehicles will arrive in t seconds, right? K number of vehicles in time t. Probability that k number of vehicles will arrive in time t is something like this, where lambda is the average vehicle rate. What is the probability that time headway is greater than or equal to time t1? What is the probability that time headway is greater than or equal to t1? So please solve this. What is the probability that time headway is greater than or equal to t1, or time headway is greater than or equal to t1? Try to solve this. This is a practice question. Try to solve this. What is the answer? What is S? What is the answer? Probability that k vehicles will arrive in t seconds is lambda t to the power of k into e power minus lambda t upon lambda factorial. Okay, then what he is asking, probability that time headway is greater than or equal to t1. What would be the probability that time headway is greater than or equal to t1, or time headway is in certain range? How you are going to calculate it? Do it, sir. Fine. See, probability that time headway is greater than or equal to certain things. So this, for this question, this is of no use. Probability that n vehicles will arrive in t seconds, if they ask that question, then you can use this. If not, he is asking what is the probability that time headway is greater than or equal to t1, right? What is the probability that time headway is greater than or equal to t1? That is generally given as integral t1 to infinity f of t dt, and f of t would be equals to lambda into e power minus lambda t dt. Lambda multiplied with e power minus lambda t dt, where lambda is the vehicle arrival rate. So what you will be doing is e power minus lambda t upon minus lambda t1 to infinity. So that would be equals to minus of e power minus lambda into infinity minus e power minus lambda t1 whole thing upon minus 1. So that would be equals to how much? 1 by e to the power of infinity is 0. So this would be simply e power minus lambda t1. Probability that time headway is more than or equal to something like this. A probability that time headway is in more than t1, you will be using this, that f of t, the function of probability, is lambda into e power minus lambda t. The function of probability would be something like this. Function of probability, it is an exponential curve. So the function of probability is generally given as lambda multiplied with e power minus lambda t. And if they ask from this, you will get this probability that k vehicles will arrive in t seconds is lambda t to the power of k e power minus lambda t upon k factorial. Fine. So here what is your answer? Lambda e power minus lambda t1. Similarly, if they ask probability that time period, time headway, not time period, probability that time headway is less than or equal to t1, then what you will be doing? Integral 0 to t1 lambda into e power minus lambda t dt. Fine. That is how you will get. Probability that time headway is in the range of 0 to infinity. Fine. So that would be equals to 0 to infinity lambda e power minus lambda t. You can also get it from here. You will get answer as 1 over here. From this, this equation is generated. Fine. So that is the idea. That is how you will try to find out. So what would be this value? I think this value would be 1 minus e power minus lambda t1. If you integrate it, you will get this 1 minus e power minus lambda t1, and probability that time headway is more than this is e to the power of minus lambda t1. If they ask probability that time headway is in the range of, probability that time headway is in the range of t1 to t2. Sir, what are you talking? Time headway. Time headway means time interval between two vehicles. Probability that time interval between two vehicles is in this range, 1 second. This is how you will try to find out. Fine. Probability that time period is in this range. Time headway is in the range t1 to t2 lambda into e power minus lambda t dt. Simple. Just integrate it, you'll get the answer. So this is our probability functions, Poisson distribution function, and if they say probability function, this is Poisson's distribution ratio. This is Poisson's ratio. This is Poisson's distribution. Fine. Distribution. So probability that some vehicles will, probability that this is time headway. Okay, this is probability that time headway is more than this. Probability that n vehicles arrives in t seconds is something like this. Fine. Any doubts in this? You can ask me. Any doubts? See, there is a question. An observer counts 240 vehicles per hour at specific highway location. Assuming that vehicle arrival at the location is Poisson's distributed, probability of having one vehicle arriving over 30-second time interval is. Try to solve this question. An observer counts 240 vehicle per hour at a specific location. An observer counts 240 vehicle per hour at a specific highway location. Assume that vehicle arrival at the location is Poisson distributed. Probability of having one vehicle over 30-second time interval is. Probability of having one vehicle over 30-second time interval is. Please give me the answer. Probability of having one vehicle over 30-second time interval is. Just now I have given you the formula. Please give me the answer. Kumar is given the answer. Soumya, I think you are slow in this. What happened? If there is any doubt, let me know. Why? Because only we three people are there here. Don't worry much. If you are having any doubts, if you want me to repeat, I'll repeat. Not a bigger issue for me. 0.27. Fine, that's nice to hear. So an observer having, so lambda, indirectly what he has given, n vehicles arriving in t seconds or k vehicles arriving in t seconds would be equals to lambda t whole to the power of k e power minus lambda t upon k factorial. So lambda equals to 240 vehicles per hour, and t would be equals to, now what he is asking, one vehicle should come in 30 seconds, 30 seconds, right? One vehicle should come in 30 seconds. So you can change this 240 vehicles per hour, 3600 seconds, 12 twos, 12 30s, 2 by 30 vehicle per second. Fine, if I substitute something like this, lambda is 2 upon 30 multiplied with 30, one vehicle should arrive, minus 2 upon 30 multiplied with 30 upon 1 factorial. So 30 30, this would be equals to 2 multiplied with e power minus 2. The value would be approximately 0.27. Fine. So for calculator, okay, you are using mobile, it's okay, no issues, not a big issue. 0.27, it's fine. So your answer is 0.27. Well and good. Next. See, if you see this question, here an isolated three-phase traffic signal is designed by Webster's method. The critical flow ratios for three phases, critical flow ratio is 0.2, 0.3, 0.25, and loss time per phase is 4 seconds. If loss time per phase is 4 seconds, then what would be the total loss time? How many phases are there? How many phases are there? There are 3 phases, right? There are 3 phases. So 3 phases means total loss time would be 12 seconds. So 3 phases, total loss time would be 3 multiplied with 4. That equals to 12 seconds. So C value would be equals to 1.5 times L plus 5 upon 1 minus Y. 1.5 times 12 plus 5 upon 1 minus Y. Y value would be 0.2, 0.3, 0.25. Right? So this is 0.2 plus 0.3 plus 0.25. So what would be this value? Total cycle length would be how much? What happens? Split screen. Oh, you're giving. Fine. So what is the answer? 3 by 2. 23. 23 upon 0.25. 23 upon 0.25. That would be optimum cycle length in seconds. Fine, what is the optimum cycle length? 92. 92 is your optimum cycle length. This is how you will try to find out. So don't worry, suddenly when these type of vehicles is being asked. Okay, so this type of questions is being asked. Now, a student riding a bicycle on a 5 kilometers one-way street. A student riding a bicycle on 5 kilometers one-way street takes 40 minutes to reach home. Takes how many minutes? 40 minutes to reach home. The student stopped for 15 minutes during this ride. 60 vehicles overtook the student, assuming number of vehicles overtaken by the student is 0. 60 vehicles overtook the student minus number of vehicles overtaken by the student is 0 during the ride, and 45 vehicles while student stopped. 45 vehicles overtook the student when he is stopped. Fine. The speed of the vehicle stream on the road. What is the speed of the vehicle stream on the road? Try to solve this. I'll give you 5 minutes time. Try to solve this. Why I am giving time? Moving car method. Moving car method only, but give me the answer properly. I know it is moving car method. You give me the answer. What is the answer, guys? What is the answer? What is the answer? 60 kilometers per hour. Soumya has given the answer. Nice. So you're good with moving vehicle estimation method. So moving car method. Idea is what? Here generally it is from moving car method. Moving car method. Fine. So in moving car method, what exactly we are going to do in moving car method is we are going to find out the traffic flow and time taken by the traffic flow. Fine. So in moving car method of, let us say there is a stream of length L. Idea is to find out what is the average speed of all the vehicles of that stream. Fine. So so moving car method, I am trying to use it over here. So what we can do this by different methods. Anyway, I'll tell you what is moving car method. In moving car method, there will be a car. There will be 4 observers in that. First observer, 4 observers will be doing 4 things. First observer will be having stopwatch. We'll be having two stopwatches. He'll try to find out what is the time taken for the travel, and time of delay. Time of travel and time of delay. Time of travel and time of delay. This is what first observer does. Second observer. First observer will be having a stopwatch. He'll try to find out what is time of travel and time of delay. And second observer will note down the location, location and cause of delay, Fine. And third observer will be finding out number of vehicles overtaken and overtaking. Number of vehicles overtaken and overtaking. Number of vehicles overtaken and overtaking. Fourth observer will find out number of vehicles moving against the stream. Number of vehicles moving in stream when vehicle is moving in opposite direction. In stream when vehicle is moving in opposite direction. Is moving in opposite direction. Fine. So that means a car will be moving over here and then it will be coming like this. One round it will be taking. Fine. So first observer stopwatches, time taken for the travel, time taken for the delay. And second observer note down the location and time cost for delay. Third observer, if you are going in the car, if you are an observer, there is an observer car that is going, it will overtake some vehicles and some vehicles will be overtaking this vehicle. Fine. So he will note down that. And once you go like this, you will come back like this. When you are coming like this, number of vehicles moving in this direction is measured by fourth observer. Fine. So after this measurement, the average time taken by the vehicles. Average time taken by the vehicles is generally given as TW minus NY upon Q, and flow of the traffic is generally given as NA plus NY upon TA plus TW. What is TW? TW equals to time taken by test vehicle to cross the road or to cross the section when it is moving with traffic. Moving with traffic here, okay? It is moving with traffic. And TA is same time taken but moving against traffic. Moving against traffic means, I told you, it takes some time to move from here to here. Time taken by the vehicle to move from here to here is TW, and it will go from here to here. Time taken by the vehicle is TA when it is moving against the stream. That is one thing. NY is generally given as number of vehicles overtaking, test vehicle overtaking minus overtaken, minus number of vehicles overtaken. Number of vehicles overtaking minus number of vehicles overtaking. Always maintain this only. Even though if you get negative, maintain this only. Fine. And NA, number of vehicles moving in the stream, number of vehicles moving in stretch when vehicle is moving against the stream. When vehicle is moving against the stream. When vehicle is moving against stream. When vehicle is moving against stream. That means when vehicle is moving in this direction, number of vehicles moving in this region. That is the idea. So from here, you'll try to find out average time taken by all the vehicles, average time of travel. You'll try to find out average time of travel from here. Fine. So, and this is flow, traffic flow. I am not giving you the proof here, I am just giving you the concept and some formulas. Okay, so this is how you will try to find out. Now coming to the problem. A student riding on a bicycle on a 5 kilometers one-way street takes 40 minutes to reach the home. So he takes how many minutes? He takes 40 minutes to reach the home, and he has stopped for 15 minutes during that ride. So he is going on a bicycle. He is going on a bicycle. He takes 40 minutes to reach the home. Out of that, 15 minutes he took break. And what is this stretch? 5 kilometers. This stretch is 5 kilometers, and time when he is moving with the traffic is 40 minus 15, that equals to 25 minutes. Because he took 15 minutes break, time taken by the vehicle I am talking, okay? Time taken by that bicycle is 25 minutes to reach that. Now 60 vehicles overtook the student during the ride. 60 vehicles during the ride. Number of vehicles overtook is 60. Number of vehicles overtaken by the student is 0. He said assume it as 0. So ny equals to 60. Okay. Now during the ride 45 vehicles while students stopped. While students stopped, number of vehicles moving is 45. And what is the stop time period? 15 minutes is the stop time period. So what will be the value of traffic flow? Traffic flow would be equals to 45 upon 15 minutes. 45 vehicles in 15 minutes. Fine. So that is 3 vehicle per minute. 3 vehicle per minute. This is vehicles. Okay. Now the speed of the vehicle stream on the road. So time taken by the vehicle stream, time of travel indirectly would be equals to ny upon q. This is TW is 25 and this is 60 upon 3. 60 upon 3. 60 upon 3 is 20. This is 5 minutes. Average time of travel would be 5 minutes, and average time of travel is equals to length upon average speed or speed of vehicle stream. So this is 5 minutes and this is 5 kilometers, right? This is 5 t equals to 5 minutes. T equals to 5 minutes. 5 upon 60 hours, that equals to 5 kilometers upon v. V equals to 60 kilometer per hour. T equals to L upon V. This is 5 kilometers. This is 5 upon 60 hours. 60 kilometer per hour. This is how you will solve this. Okay. Only one person is watching, that is me. No other person is watching. Thank you very much for that. Any doubts in this? You can ask me. Any doubts in this? You can ask me. Any doubts, guys? Can I move to the next question? Hemant, I think you are not able to solve this. Now is it okay? Yes, next. Fine, next. 60 kilometers per hour. Any other things you want me to discuss? While traveling, try to solve this question. While traveling along and against this traffic stream, a moving observer measured the relative flows as 50 vehicles per hour and 200 vehicles per hour respectively. The average speeds of the moving observer while traveling along and against the stream are 20 and 30 kilometers per hour respectively. The density of the traffic stream is, what is the density of the traffic stream, he is asking. Try to solve this question. While traveling along and against the traffic stream, a moving observer measured the relative flows as 50 vehicles per hour and 200 vehicles per hour. Okay. The average speeds of the moving observer while traveling along and against the stream is 20. The average speed of observer 20 and 30 kilometers per hour. The density of traffic stream. He is asking what is the density of the traffic stream. Try to find out. Try to find this out. Do it. Please try to solve it. Three. Fine. So how you are going to get when it is moving with the traffic? When it is moving with the traffic. So here comes an important thing. Relative flows. The same thing, this is also moving car estimation method of type of thing only. So when, if it is moving with the flow, like if two trains are moving, then relative speed, how will you calculate? V1 minus V2, right? So when it is moving with the flow, the relative flow is generally given as Q minus KV. That is given as 50 vehicles per hour. Similarly, when it is moving against the flow, the relative flow is given as Q plus KV. That equals to 200 vehicles per hour. But here V1, V2, because it has changed. q will not change, but v1 v2 change. He has given 20 and 30. So if I subtract this from this, kv2 plus kv1 equals to 150, right? Subtracting this from this minus q minus kv1, that equals to 50. You'll get this. So that is k times, that is 30 plus 20 equals to 150. K equals to 3 vehicles per kilometer. The idea is you should know how to apply this. So when it's like an analogy is same. When two trains are moving, the relative speed is v1 minus v2. When two trains are moving in opposite direction, the speed is v1 plus v2. That is, the flow is also the same thing. Q minus kv1 and q plus kv2. Fine. So this is how you'll try to solve this question. Question number 26. Fine. So I think majority is solved. This is one of the concepts. See, there will be many theoretical questions. For that we can't do anything. We can't open the code. Sometimes if your time is bad, they'll ask theoretical question. We can't do anything. Leave it. And there is this question. A priority intersection has a single lane one-way traffic road crossing an undivided two-lane two-way traffic road. The traffic stream speed on the single lane road is 20 kilometers per hour and speed on two-lane road is 50 kilometers per hour. The perception reaction time is 2.5 seconds, coefficient of longitudinal friction is 0.38 and acceleration due to gravity is 9.81 meters per second square. A clear side triangle has to be ensured at the intersection. The minimum lengths of the sides of the side triangle along the two-lane and the single lane road respectively are. So once these type of questions comes, you feel like you haven't studied it. Actually you haven't studied, not only you, throughout India no one did this. So don't worry about it. This is like side triangle concept. A new concept comes. Every year new concept comes. You have to leave those questions. You won't have a choice. You should not get panicked. The idea should be very simple, that if you are not able to do that, no one in India will be able to do that. That should be the confidence, okay? Because whatever you studied, he studied. Maybe if 1 or 2% studied extra, fine, that is his luck. Fine. So there is a one-way road, this is a one-lane road, and this is a two-lane road. And this one-lane road is called as minor road. This is called as minor road, and this one is called as major road. This one is called as major road. Okay. So as per guidelines of IRC, if let us say a vehicle is coming like this and a vehicle is coming like this, if these vehicles see properly with each other, then there will not be any collision, right? This is called as side triangle. This one is called as side triangle. This is called as side triangle. So that idea is to avoid the collision, a perfect side triangle should be maintained. And according to IRC, the side of the side triangle on minor road, the length of the side of side triangle on minor road would be 15 meters. It is how much? It is fixed. This is minor road, single lane road, this is double lane road. So two lane two-way road. This is major road, this is minor road. So the length of the side triangle is 15 meters. And length of the side on the major triangle is distance traveled by the vehicle in 8 seconds. What is that? Length of side on major road. Length of side on major road equals to distance traveled by vehicle, distance traveled in 8 seconds. Distance traveled by vehicle in 8 seconds. What is the speed of the vehicle on major road? Speed of the vehicle on major road is 50 kilometers per hour. So this is 50 kilometers per hour. 50 multiplied with 5 upon 18, multiplied with 8. I think approximately you'll get 111 meters. Fine. So this would be 111 meters. Distance traveled by vehicle in 8 seconds. This is how you'll try to find out the sides of the this is side triangle on minor road and on major road. Fine, if this is maintained, this is the side triangle. If you design it in such a way that side triangle is maintained, then you can avoid accidents. So here SSD, all those things is given. People tried with SSD from here, SSD from here and all those stuff. That is wrong. As per IRC guidelines, you have to solve this and your option is C. Okay. Any doubts? Any doubts in this? Any doubts in this? If you want me to solve any other questions, let me know. I'll try to solve it. So small break even, sir. So you want small break or total break for the today? Because tomorrow we can do once again. Tomorrow like three chapters today and 3 chapters tomorrow. If you want, then we'll stop the class today here. We'll stop the class today here and then we'll continue tomorrow. And you can read whatever you want to read in the evening from 6 to 9. Other subjects that you wanted to read, you can read. Yes. Are you serious? Do you have energy? Because I don't think so people will be having energy. They'll be bored and I want you to enjoy this. So it's better if you stop it here. 9 to 5, I think it's sufficient. And tomorrow we take another 9 to 5. Or 9 to 1, we'll stop this and we'll start another section for tomorrow. Another subject that you want me to do. From the afternoon, we'll do that. In the evening, try to revise whatever I have said. Or try to just go through what we have discussed. Is that okay with you? If not, we'll take a half an hour break and then we'll start once again. What do you want me to do? Yeah, you're enjoying my class, it's okay. Just make it fast. Half an hour break or class for tomorrow. 2 options. Yeah, understood. Half an hour break or class for tomorrow. It's not only you, Soumya is also there. She has to say. తెలుగులో కదబ్బా చెప్పండి తొందరగా కంప్లీట్ చేద్దాం. నన్ను అడిగినంతవరకు కలిసిపోయి ఉంటారు మీరు. రేపు తీసుకోవడం బెటర్. Fine, we'll stop the class today here. Tomorrow from 9 o'clock once again we'll take the class. We'll try to complete transportation, railway, air by afternoon only. Not a big issue. Okay. And after that, please let me know what is the another subject. I'll create the link for another subject also. What you want. Okay. Bye. Have a nice day. And we have discussed two major topics I have discussed: geometric design of highways and traffic engineering, which will be very useful. So we'll stop the class here, and tomorrow whatever that you want for in the morning session from 9 to 12 or 1, we'll try to finish off transportation, and the rest whatever the subjects you want will start. Fine, I'll try to create the link for that also. I'll let you know. Okay. Okay, bye guys. And what is the best thing to do? Either you see this for another half an hour, whatever you have studied from morning to evening, just go through for another half an hour, all the whole video, half an hour it will be enough, and try to read whatever the subject you wanted to read. Okay, and tomorrow we'll try to finish it off transportation. Fine, bye, and please do like, share and subscribe. Thank you.